This course is an end-to-end guide to mastering MLflow, the industry standard for managing the machine learning lifecycle. This course offers a deep dive into the internal mechanics and architectural patterns of MLOps, from your first local experiment to deploying production-ready models via a centralized tracking server. You're going to gain the hands-on expertise required to build reproducible and scalable ML systems. You'll learn how to use Databricks to integrate MLflow's tools into professional workflows as a single source of truth for your entire model registry.
Hi everyone. If you are learning machine learning, MLOps or GenAI, at some point you will hear this question often. How do I track experiments properly? How do I manage models, parameters, and metrics? And if you are dealing with LLM, then how do I manage prompts? That is exactly what this video is about. In this complete end-to-end session, I'll walk you through MLflow, not as isolated features, but as a real system that is used in modern MLOps and LLM Ops workflow. This is mostly practical working understanding kind of video. You won't be looking at too much theory except for the first video. And across this video, you will see how MLflow is used for experiment tracking, parameters and metric logging, model versioning and lifecycle, MLOps workflow, and then there will be LLM Ops as well, like how do I manage prompts, how do I load prompts, how do I evaluate prompts, and things like that. If you are a student, a working ML engineer, or someone transitioning into MLOps or GenAI, this video will give you a solid mental model of how MLflow actually fits into real projects. You don't need to watch everything in one go. Treat this like a reference guide you can come back to. Now let's get started and build a clear understanding of MLflow from the ground up. Hello everyone. In this video, we are going to discuss about the most important and fundamental step before we actually begin, doing hands-on with MLflow. And that is why ML systems need experiment tracking beyond notebooks and Gits. So let's get started. So I have not made these presentation slides very text heavy because I wanted to give you the gist of why MLflow exists without drowning into too much details. Okay. So here, if you see this diagram, this on the left represents a mess, and this on the right represents something which is ordered and connected, and it has some connections. So we are saying this as from ad hoc experiments to production ML systems. So before we actually dive into anything of that sort, we are going to talk about how most MLflow projects start. So usually, if you have built a machine learning model, you start with a Jupyter notebook. Okay, so that is one notebook, and you will have one data set. It could be locally downloaded in your laptop or in your compute instance, whichever you are using, or it could be very small data set. Okay, it could be a large data set or small data set, or it could be present in a cloud repository or in your local notebook where your notebook instance is running. Now, there is one model also. Initially, at least you will have one model. You won't be doing much experimentation and fine tuning, that sort of thing, and one person. And for most of the people, this is fine. And if let's say you are into academic and you are doing some sort of research where you have not more than maybe one or two people, in those scenarios, I don't think MLflow should be used also, because it's like wasting more time on these tools if you don't have that much requirement. Okay. So let's move on. Now I have basically given some naming convention that people usually use in their initial stages of machine learning experimentation, they will have some sort of naming for their notebook. They will have some sort of model naming, the model that they trained and that they think is the best. Not think, but based on the metrics, they think they have come to this conclusion that this is the model which is best. And there's a lot of confusion here. Why I'm saying this is a confusion? Because you might be working in an organization where some 10-20 data scientists also exist, and in those scenarios they will have their own mess. Okay, and if you have to communicate effectively, you won't be able to and you can't trust your memory here. So that's where the confusion exists, and this is where my next slide points to: the hidden assumption. We humans tend to overestimate our power to remember. We say, I'll remember how this model was created, but this does not always happen. We always forget. You have to trust your experience, not your mind, because your experience tells you that you forget, but your mind will tell you, no, I'll remember. I don't have to write it down. Okay. So what is the difference between machine learning and traditional software building? In traditional software building, you have something which is known as deterministic outputs. You have a given piece of code that will result in a given artifact or given deployment, but that is fixed. But in machine learning, the outcomes are probabilistic in nature because we are dealing with data and randomness here. So that is why here the meaning of version differs from software building. In traditional software, we have version of code, but here version means something close to decision history. So you have got a different set of tuning parameters, hyperparameters that you can tweak a little bit, and then your result will be drastically different. So those parameters have to be logged. Now, what is an ML experiment? What is an experiment? So you can think of experiment as some sort of encapsulation of all these 5 components. These 5 components are code. Obviously, without code, you can't train. You will have data. You will have parameters. You will have randomness, and there is this 5th point which I think most people overlook, and that is environment, because you must be using some sort of packages in your training experiments. So that environment also has to be considered as a part of ML experiment. Okay, so these 5 things will create your experiment. Now, what Git captures and what Git cannot capture. So Git only captures code changes, and that is why we are talking about something different than what traditional Git offers for machine learning systems and experiment tracking. Now, why notebooks don't scale? They don't scale because, first of all, the most primary reason is that there is no structured metadata. So you run things line by line, cell by cell, and you don't have a track of how many models you have trained within one notebook or across several different notebooks. You don't have a inherent execution order. Okay, no structured metadata, and there is very it is very hard to compare runs. Runs means within an experiment you can have multiple runs. We'll talk about that in maybe later videos. So what is a core problem? Core problem is that ML systems lose this decision history, and this decision history is what we are trying to capture using MLflow. Now, why this becomes a dangerous thing in production? Because production requires us to train our model again and again. Why? Because data changes, team changes, and a new person comes. That new person probably wants to reproduce what the old person has created. And not only that, your infrastructure will also change. You might be working in GCP right now, but you will have to, let's say, switch to Azure. Those things are not in your control because management can decide to change these things at any moment. So every production team must answer why a given model is in production. We should be clearly able to articulate why a given model is 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 basically pushed to production. What is the reason for that? Maybe its accuracy is changed, but maybe its accuracy is best, but just answering that its accuracy is best is not enough, because you will have to answer a lot of different things. Okay, so what happens without tracking? So you don't have reproducibility, you don't have auditability. Now this is very important, because in a tight organization, when I say tight, what I mean is where these compliance checks are very heavily enforced. In those type of organizations, auditability is something that needs to be taken very seriously. So so this particular thing cannot be achieved without tracking. Okay, you can't audit through a notebook. Okay, no safe rollbacks. Let's say if you have a model in production and if you would like to go to some other previous healthy version, you can't do that. Obviously you can do that, but there are manual things that you would like to you would have to do. Okay, so now some of the excuses of not applying these principles of MLOps and MLflow are as follows. We will clean up our code later. The code which exists in notebook, we are going to clean up it later. They will say this is just a research, and I feel this excuse can be taken if, let's say, you have a single person team and you don't have much organization and collaboration. Then I think that's fine. Tracking slows us down. Tracking will never slow you down. Tracking will only enhance your future productivity. So those things are some of the common early stage excuses that people make. Now what breaks? We all know folder based tracking, where we, let's say, create a folder for, let's say, something like experiment this. Maybe we are testing a new feature within our training pipeline, so we'll create a new folder for that experiment. We'll create a spreadsheet comparison. That also does not work. And we sometimes also make memory based decision because we overestimate our power of memory. Okay, so essentially this is a systems and discipline problem, and this problem is actually a problem when we are dealing with an organization which is very involved in compliance checks, and it's a huge organization having multiple data scientists and multiple people working on a problem. So what experiment tracking actually solves? So there are few things that experiment tracking can help you with. First is decision traceability. You can trace what led to a given decision. For example, what led to a model being pushed to production. You have got systems memory, team alignment, and production safety. So how it leads to team alignment? Because everybody is aligned on, let's say, a given model being pushed to production. They know why it is so. They can clearly go into a centralized tool such as MLflow server, which we are going to talk about later, and clearly see why a given model has been pushed into production. Okay, so yeah, okay, so now I think that would be it for this particular video. There in this video I just wanted to basically give you an motivation to use MLflow within your organization setup. And we won't be doing any MLflow APIs and UI walkthrough just yet. We'll be doing that maybe in next video. But yeah, that was the intent of this video. I hope you liked it. I'll see you in the next video. Thank you so much. Hi everyone. In the last video, we discussed why it is important to consider using MLOps, or in particular MLflow, in your machine learning projects and systems. Now in this video, assuming that you are satisfied with the reasoning that I gave you and ready to basically work with MLflow. In this video, we are going to be setting up MLflow within our local system, that is laptop, but you can reproduce these steps to basically run it even in your cloud environments. In cloud environments, you would have to do extra step to configure the UI part, because here in laptop, I can simply run a local server and open localhost to get started with UI. But in cloud, let's say if you are working with cloud shell, there you would have to, maybe depending upon which cloud platform you are working with, you would have to do some extra step to enable that UI. So let's get started. What I'll do is I've created a separate folder, MLflow YouTube. Now within this folder, I will create my demonstration, all the scripts that I will be using for demonstration. Okay, so let me do one thing. Let me open terminal, and in this terminal, what I'll do is I'll first of all navigate into documents and then MLflow YouTube. Okay, and in here I can open my Visual Studio Code. Okay, so we are now in the Visual Studio Code. I won't be using any AI help in this video, but I will be copying a lot of code from the documentation of MLflow. So let's get started. So first of all, I would like to, maybe I will use its own Visual Studio Code's terminal, and let's create a virtual environment here. Okay, so I will do something like okay, so we have Python installed. You would have to make sure that Python is installed on your system. So I have Python 3.11.2, and I'm actually using venv to work with multiple versions of Python. So if I do Python 3, I'm getting this, but I can also, one second, get other versions using venv. That I won't be covering and boring you in this video. So what I'll do is I'll create a virtual environment here in this directory using this name. Okay, so now what I'll do is I'll activate this source, then bin and activate. Okay, so our virtual environment has been activated. Let's quickly install the MLflow package. It would take a couple of seconds. It should not take much time. And meanwhile, what I can do is I can come here on the documentation and I can go on quick start and I can copy this. Maybe what I'll do is I'll just copy this script, or I'm hesitant in copying, but let's create a lecture1.py. Okay, inside here I will import MLflow. Okay, currently it's not using my local venv. That is why you see these curly lines, but that should be fine for now. Now after this, after basically accessing this, the first step is to set the experiment. I will name my experiment as maybe something like, I don't know, a demo experiment. Okay, and then I can run this script. Okay, so first of all, I will say Python lecture1.py. It should do nothing, I guess, at this point, but you will see bunch of things getting created here. It will take some time. Let's wait. Okay, so you see this, a new directory called mlruns is getting created, but here nothing else happened, right? But let's start so basically when you install MLflow, what happens is you get a command line tool with the name MLflow. So if you run this MLflow, you see all these options to work with MLflow's commands. So MLflow server, and you will see all the commands related to server, but it started the server on the default port. So let's open the server now. 127. Okay. So I'm getting this server. You see these tabs: home, experiments, models, prompts. Because now earlier in the earlier days of MLflow was used only for traditional machine learning, but nowadays it has been used for GenAI based experiments as well. So you see these prompts here. So if I come here in the experiments, you see my demo experiment. If I click on it, 1 second, it's asking me because it's my first time I'm visiting this dashboard. I'll just confirm this. Okay. So yeah, so this is what I wanted to show. Now this server will continue running. We'll talk about this ML runs directory in a moment. Okay, so I hope you understood what I wanted to demo in this video. Now we are set up with the MLflow. In the next video, we'll be creating our first brand new experiment, and also in that experiment, we'll be creating a new run. Okay, so thank you so much for watching this video. Have a nice day. Hello everyone. In this video, we are going to create our first experiment, and also within that experiment, we are going to create bunch of runs. I hope you are excited. Let's get started. Okay, so we already have this code, but let me create a new file for lecture 2.py. Within this, I'll just copy this and paste it right here. Okay. Now that this set experiment is basically called here, anything that I call after this line will be logged within this experiment. Okay. How do I create a run within this experiment? Since experiment has already been created, what I can do is I can start with the MLflow dot start run. Now this start run will create a context, and within this context I can do some sort of logging. But for now, let's keep it very simple, and I will log, let's say, log params. I'm calling this function log params, and let's pass dictionary here. Maybe I have a hyperparameter. Hi everyone. In the last video, we discussed why it is important to consider using MLOps, or in particular MLflow, in your machine learning projects and systems. Now in this video, assuming that you are satisfied with the reasoning that I gave you and ready to basically work with MLflow, in this video we are going to be setting up MLflow within our local system, that is laptop, but you can reproduce these steps to basically run it even in your cloud environments. In cloud environments, you would have to do extra step to configure the UI part, because here in laptop I can simply run a local server and open localhost to get started with UI. But in cloud, let's say if you are working with cloud shell, there you would have to, maybe depending upon which cloud platform you are working with, you would have to do some extra step to enable that UI. So let's get started. What I'll do is I've created a separate folder, MLflow YouTube. Now within this folder, I will create my demonstration, all the scripts that I will be using for demonstration. Okay. So let me do one thing. Let me open terminal, and in this terminal, what I'll do is I'll first of all navigate into documents and then MLflow YouTube. Okay. And in here, I can open my Visual Studio Code. Okay, so we are now in the Visual Studio Code. I won't be using any AI help in this video, but I will be copying a lot of code from the documentation of MLflow. So let's get started. So first of all, I would like to, maybe I will use its own Visual Studio Code's terminal, and let's create a virtual environment here. Okay, so I will do something like okay, so we have Python installed. You would have to make sure that Python is installed on your system. So I have Python 3.11.2 and I'm actually using venv to work with multiple versions of Python. So if I do Python 3, I'm getting this, but I can also, one second, get other versions using venv. That I won't be covering and boring you in this video. So what I'll do is I'll create a virtual environment here in this directory using this name. Okay, so now what I'll do is I'll activate this source, then bin and activate. Okay, so our virtual environment has been activated. Let's quickly install the MLflow package. It would take a couple of seconds. It should not take much time. And meanwhile, what I can do is I can come here on the documentation and I can go on quick start and I can copy this. Maybe what I'll do is I'll just copy this script, or I'm hesitant in copying, but let's create a lecture1.py. Okay, inside here I will import MLflow. Okay, currently it's not using my local venv. That is why you see these curly lines, but that should be fine for now. Now after this, after basically accessing this, the first step is to set the experiment. I will name my experiment as maybe something like, I don't know, a demo experiment. Okay, and then I can run this script. Okay, so first of all I will say Python lecture1.py. It should do nothing, I guess, at this point, but you will see bunch of things getting created here. It will take some time. Let's wait. Okay, so you see this, a new directory called mlruns is getting created, but here nothing else happened, right? But let's start so basically when you install MLflow, what happens is you get a command line tool with the name MLflow. So if you run this MLflow, you see all these options to work with MLflow's commands. So MLflow server, and you will see all the commands related to server, but it started the server on the default port. So let's open the server now. 127. Okay, so I'm getting this server. You see these tabs: home, experiments, models, prompts. Because now earlier in the earlier days of MLflow was used only for traditional machine learning, but nowadays it has been used for GenAI based experiments as well. So you see these prompts here. So if I come here in the experiments, you see my demo experiment. If I click on it, 1 second, it's asking me because it's my first time I'm visiting this dashboard. I'll just confirm this. Okay, so yeah, so this is what I wanted to show. Now this server will continue running. We'll talk about this mlruns directory in a moment. Okay, so I hope you understood what I wanted to demo in this video. Now we are set up with the MLflow. In the next video, we'll be creating our first brand new experiment, and also in that experiment we'll be creating a new run. Okay, so thank you so much for watching this video. Have a nice day. I will try to create a new run here. Okay, all right. So MLflow dot run name test artifact, and in place of parameters I would like to log artifact. And here I want to pass the artifact path, but let's, for the sake of demonstration, log the lecture1.py file. And let's run this really quickly, lecture2.py. Let's see what happens. So it's run. Now let's look at the test artifact in the demo experiment. So in the test artifact, if you see artifacts, I have got this test.py. So this entire test.py got created. Now if I open ML runs, you see certain structure is being followed. What is this structure? So let's go and find out. So in the ML runs, you have got this folder for one corresponds to the experiment name, experiment ID, sorry. So this one, and in fact you can see it here also. In the one is for experiment ID. What is this 60? 60 stands for the run ID. So if I go to the test artifact again, so run ID is this 60. What is this artifacts? Artifacts is, as the name suggests, it's for saving the artifact and the actual artifact. I can use it to save pickle files. I can use it to save images, data sets, anything that you can think of that should not be saved in a DB. Now let's see what exists within the MLflow.db. So let's explore. Let me close this out and let's explore. Not here. One second. Explore DB. Explore db.py. Okay, so this DB we can connect using SQLite. So import SQLite 3, and here what we need to do is we need to create a connection. Now how can I create the connection? I can simply write something like connection is equal to SQLite dot connect. In the connect, I can pass the name of this database that is created locally. Connection is equal to this. Now this connection, I can extract all the tables. So let's also import Pandas for this demonstration. Pandas as PD. And here PD dot read SQL query. And here I will say something like select name from SQLite master where type is equal to, I will put it inside single quotes. In the single quotes I will write table. So I want to get all the tables and I would like to close this. Now this is the query, and what is the database? I will just pass the connection, and let's try to print the tables and let's see what do we get. So what is exactly stored in here? Okay, so you see there are like lot of details which are there, for example score versions, evaluation data sets and things like that. Let's try to explore one of these tables. Let me see which table can we explore. So we have got runs table. This is what I am interested in. So now I will say runs df is equal to pd dot read SQL query select star. I would like to select all the things from runs. I would like to close this query and I would like to call it on connection. And now let's print the head of this runs df dot head. Okay, so let's run this now. Okay, you see this run UUID. Now what is this UUID? But let's for the time being remove all. Let's try to print all the values, and you see 60. This 60 is the run that I actually created just now. So I hope you are able to see why what is the objective of this. Let's also try to print columns. So you see run UUID, name, source name, entry point name, user ID, all these details are logged here. Okay, so now whatever I have explained just now, there is a technical name for both of these. This store that I'm using to store the artifact is known as artifact store. Okay, this database that I'm using to store all the parameters metrics is known as backend store. Okay, and then this server that I'm running here, it's called tracking server with its UI also. So UI plus this service that is serving this server is known as tracking server. So these three are one of the important concepts that you have to remember while using MLflow. Now the next question arises that is it advisable to store these artifacts within your local setup? No, it is not. In fact, what we do is we store these artifacts in some object storage which exists in various cloud providers like S3 or maybe GCP storage bucket, etc. And the same goes for this backend store. This backend store we can go for Postgres or SQL server, MySQL server, anything that you can get access of. Now, how can we actually configure that? That is a topic of another discussion that I can probably have later, not right now. Okay. So I hope you have been able to understand what I wanted to show you. The primary thing that you have to take away from this video is that ML runs directory stores your artifacts, MLflow.db stores your metadata and run properties. Thank you so much. I'll see you in the next video. Hi everyone. In the previous video, we discussed about what this ML runs directory points to and what does this MLflow.db contains. And we were able to understand that MLflow.db is nothing but a database referencing all the metadata, tags, and run history, whatever we create during the run. In the ML runs, we can log any artifact that would traditionally the database will not be able to hold. Although we can store it in binary format, but the idea is that backend store, or rather I should say artifact store, should be used for something heavy, such as your pickle files, datasets, anything of that sort. In this video, I would like to take a moment to discuss a list of comprehensive items that you can potentially log during a run. So let's get started. So I'll create a new file called lecture4.py. Let's import MLflow. And inside this, I would like to set the experiment MLflow.set experiment, and I would like to call this experiment as YouTube tutorial. Okay, what's better to call an experiment than to call it YouTube tutorial? Okay, all right. So after setting this experiment, what is the next thing that we want to do? We would like to create a run, right? Start run. And let me create a run name. And run name I'm going to call as, maybe, I don't know, I can call it as logging demo. Okay. Now, what are the different things we can log? First of all, I can log parameters. And there are two ways to log parameters. Key value parameters and a dictionary parameter. So naturally, it exposes two methods to log these two. I can say something like log MLflow.log params. I can call log param and I can provide the key. So for example, I would like to log learning rate of my machine learning algorithm. Let's set it as 0.03. And I can log learning rate, maybe epoch, and epoch can be 100. Okay, so this is log param, sorry. And then there is a method by which you can have a parameters dictionary, and inside this dictionary you can have learning rate. Maybe I'll keep it as 1, 0.04, and then epoch 1. And the epoch 1 can point to 200. Now I can log this entire dictionary in a single shot by doing log params, and inside the params I can pass parameters. Now let's view the output really quickly. I would like to run this script, and I would like to also capture its run ID, so I can reference this at a later stage. Okay, let's first, and I would like to also test whether I can specify run ID or not. Let's test it out. Maybe I can specify a run ID of 123. I have not tested it because I got this idea just right now, whether we can provide a custom run ID or not. I feel it should not happen, but let's see. Okay, so run with run ID. Okay, it assumes that if you provide a run ID, it will start looking for it. So let's first create a run. Okay, so it's successful. Now what I can do is, okay, YouTube tutorial, and in this we have got logging demo, and inside here you can see learning rate, epoch, learning rate 1 and epoch 1. Okay, so we have got this ready, but now I would like to capture this run ID, and I would like to get this here because I want to demo this within the same run. I don't want to create unnecessary runs. Naturally, after parameters, we can have metrics, and inside metrics also this is a similar pattern. We can let me show you. MLflow.log metric, and it's like a key value pair. Maybe I can log a accuracy, and accuracy could be something like 90%, and I could also do something like log metrics, and this log metrics could be a dictionary. And here what we can do is we can define a metrics dictionary. Previously, like the way we define parameters dictionary, we can in a similar fashion define metrics dictionary. This metrics dictionary can have something like accuracy, and since I have already added one accuracy, so I would like to rename this accuracy as accuracy 1, and let's put it as 80. And here I would like to pass this metrics dictionary, and let's run this. This time it won't throw. One second. I see. I think this is not allowed. Let's rerun this. Okay, so this time it did not throw an error regarding the run ID, because this run ID we already made sure that this exists, and now that this run with this run ID exists, we can go ahead in the UI to see the output. So we see the metrics appearing here. We have accuracy and we have accuracy 1. Sweet. Now let's move on to logging some other bunch of stuff. The third possible things that we can log is artifacts, and artifacts would be appearing here. Okay, so you see currently we have only one experiment being listed here because there is only one artifact so far we logged, and that is lecture1.py. But now let's try to log some image. Okay, and the main thing is that to log any artifact, the interface remains same, and the interface is that MLflow.log artifact. Before logging the artifact, you need to get the artifact path, and that artifact path can come from anywhere. For the time being, let's assume we have some training job which is running for some number of epochs, and we need to look at the learning rate progression, or maybe loss progression. So I can say something like loss graph machine learning. Okay, so what we can do is we can grab this graph and we can save this image in the directory where we are having this project, and I can call this as anything that I want for now. So we have this images.png. Okay, so now I can do images.png and I can log this artifact. So let's log it. So a lot of things will change after this. First, if I open ML runs, you will see two directories, two subdirectories are appearing here. The first directory is the previously created experiment, and second one is this YouTube tutorial. If I open the second one, you will see 890, and 890 is the run ID. Inside it, we have images.png. This is exploring, this is basically viewing the artifact within the directory, within the store. We can view the artifact here also. If I go inside the artifact and if I click on this, you can see this image appearing here, and we can zoom in again. So this was about logging artifact, and you are not limited in the manner you are limited in logging params or metrics. In artifact, you are free to log whatever you want, but this power should be used very cautiously, because just because you have the ability to log anything, you should not misuse your storing server. Whatever storing server you are using, currently we are on our local directory, but you might be given access to a object storage in a cloud platform. You don't want to misuse that. Okay, so there are some, although I personally think that these three covers most of the stuff, but there are some other cool things that you can do. So for example, log image is one such thing. If you see, this logs image in a image ND array. If you have worked with deep learning based on images like CNN, you might already be aware that a image can be represented as an ND array. So that array you can directly provide here. Okay, so you can log that like this, or you can save that image or log it separately. Okay, and then there are other methods for logging tables as well, such as log table. Inside it, you can pass the data like this. So you can either pass a data frame. Let's create a data frame really quickly, and let's see where does that appear. So import pandas as PD, and let's create a demo df. PD.data frame, and inside here, let's create a data frame with only one column called name, Daniel, Sam. Okay, so now I can log this df. Let's see, what do we see? What do we get? It says artifact file, which means we want to provide the artifact file name also. Let's say I want to name it as demo.df.data. Okay, let's see what, which means when you go inside the UI, it will be appearing in the path that you specify here. Invalid artifact path. Please ensure the file you are trying to. Okay, JSON. Let's provide JSON here. Okay, so if I now go inside here, you will see demo.df.json and you see this table appearing. Okay, so you, in this way, you can see that you can possibly preview also data. So if I click on these tables, I can possibly preview. I can sort it out if you have very large tables. So let's do one small project. Let's load some large data here. Let me download maybe Titanic CSV. Okay, so let me grab this file and let me put it inside the, and now let's go inside here and let's read this Titanic df pd.read csv Titanic.csv, and inside log table I will pass the Titanic df Titanic.json. Okay, let's run this. It should be able to log, and now if I refresh it, we should be able to see our Titanic.json. But this time this is taking some time, and you get this nice looking table which you can obviously click and you can sort it out, sort the whole table. You can sort, so you can do really cool stuff. And not all the rows are loaded. You see, there is this pagination option with which you can move through various rows to view it. Okay, all right, and you can also choose columns if you go for compact view. Okay, so these are different options that you get out of the box from the log table. I think that would be it. There are other options also. So for example, if I show you MLflow .assessment, so you can log assessment also, and assessment would take a trace ID. Now this becomes important when you are dealing with let's say GenAI based applications. So we have got figure. Now figure is similar to image. Here you have to pass a matplotlib based figure object, and that will be basically rendered in a artifact here. Okay, so there are multitude of options that you get in MLflow based logging. So I'll stop this video right here and then I'll continue with next topic, that is model registry. Hi everyone. So in this video, I want to start talking about logging models. Now models, if you are experienced in machine learning, you might be aware that models can come in various flavors. You can be building models in Scikit-Learn or PyTorch or maybe TensorFlow. All these different frameworks have their own set of requirements and dependencies that you need to keep in mind before you actually log the model. Now there could be a manual logging step or a auto logging step. There are two different ways by which you can log, and in this video I want to show you the manual model logging using Scikit-Learn. So let me create a new script called lecture5.py. Inside this script I will, or maybe let me grab some training scripts from the MLflow quick start, because that will make our job a lot easier. So we have got this this training data, this training script from MLflow documentation, and let me also grab the train model. Okay, so you see this auto log. So they have enabled it. For now, let's comment it out and let's run it. And let me also confirm if my server is running. Okay, so let me now go in the tracking server. I think it would be 127. Yeah. So this is the tracking server we have. So now let's first of all run it as it is to see whether we are getting any error or not. Okay. So let's see. It's running. Let's see why it is taking so much time. Not sure. 1 second. Okay, so it's saying it's got unexpected argument called multi-class. Why? Let's comment it out then. Yeah, so now our model is being trained. But where exactly is this model? We don't know yet because we have not saved it somewhere. Let's create an experiment. MLflow dot set experiment. Scikit-Learn model logging. Okay, and inside it, let me start a run. And let's move these training lines within this. And now what we can do is, we can also name this run and also log this params. Run name would be Scikit-Learn model logging. So this run name is Scikit-Learn model logging, and now what I can do is I can do MLflow dot log params, and inside it I can pass params. Okay, so how do I log this Scikit-Learn model? What I can do is MLflow dot log model. Okay, no, sorry. I need to call the flavor first. The flavor is here Scikit-Learn. So Scikit-Learn dot log model, and inside it first argument will be SK model, and the SK model is LR, and second argument will be model name, and name will be, let's say, simple model. Okay, and let's run this. Okay, so our run is complete. Now let's move to check whether our UI has been updated or not. So we have got Scikit-Learn model logging, and inside it you can see our params are listed here, and logged models. Inside logged models we have got this, and model name is simple model. If I click on it, so this basically shows us models. Okay, now if I go inside the ML runs and open the third experiment, and third experiment corresponds to Scikit-Learn model logging, then I will see a models directory. Now this models directory is corresponding to this model ID. Now model ID, so this model, this simple model has this model ID. Okay, so that's how it is basically able to reference it. Now once this model is logged, we can do all sorts of cool things, such as I can register this model. Now there is a difference between logging a model and registering a model. These two are entirely different things. Logging a model just means you put it inside a dump in a repository or in a storage. Registering a model means now you can use that registered model to actually deploy to a HTTP based endpoint that is supported by MLflow. So far we have seen that how we can use this to kind of get a manual logging. Let me now copy this, and inside here I will name this as auto. Now this time I won't be logging anything. I will just be training the model, and MLflow will auto detect all the required parameters, matrices and all, but I'll just need to enable the auto logging feature. Let's run this script now. So after run has been completed, it will take some time because it is generating some metadata and some graphs and all. So let's go to, okay, so now I have got, one second. So now I have got two runs. You see auto and logging. So let's open auto, and inside auto you see several different arguments like parameters. Now where are these coming from? These are coming from MLflow's backend compatibility with sklearn. So it is able to detect all these automatically. We have model metrics, we have system metrics, we have traces and artifacts. In artifacts we have we have training, confusion matrix, etc. Now what I can do is I can go inside the logged models, and inside the model I can see a similar structure. So ML model conda YAML model pickle. So model pickle is the actual binary, and all these are just different ways to manage the dependencies, such as requirements.txt, python env.yaml, MLflow, etc. So that's how we do manual logging with a flavor of sklearn, and also that's how we do auto logging with a flavor of sklearn. The process remains same for other flavors as well. The primary thing that you need to know is how to locate your desired artifact. So for example, here I see models. I've got two models. I've got this run, which was created when I enabled the auto log. I hope it makes sense. Next, we will cover model registry. Thank you so much. Hi everyone. In the last video, we talked about how we can take the registered model and deploy it. Now, I would like to switch gears a little bit and talk about some of the cool capabilities of MLflow that make it really exciting to use. In this video, we are going to be looking at nested runs in MLflow. Let's see what do they mean. Lecture 7.py. I'll just quickly import MLflow. I will set my experiment as nested run demo, and we will get started with the creation of nested run. So the idea behind nested run is that there would be a parent run. Okay, let's create a parent run first. So MLflow dot start run, and inside here I will call this run name as parent run. Okay, and we can also alias this context manager just like we do it while opening a file. So as parent run, we can print its information parent run, maybe parent run dot info dot run id. Okay, and then within this we can, so let's first log the, so MLflow dot log param theta, and let's say 100. Okay, let's create a child run within this. I can specify the run name as child run 1 as child run 1, and here I can print Control C its properties child run, and here inside here I can specify child, and I can copy paste it multiple times to create multiple child runs. Okay, so I'll say child run 2, child run 3, child run 2, child run 3, child run 2, and child run 3. Now let's run it. Although I can also log things, but let's just run it the way it is right now. Okay, so we are getting some error. Let's see where exactly is the error. It's saying run with. Okay, so I think we need to provide the parameter as nested is equal to true. Nested is equal to true. One second, not here, sorry, not in the parent. So parent run was created, but since parent run was active, child run, we could not create child run. Let's print, let's pass the nested is equal to true. And let's use nested is equal to true here as well. Let's run this one more time. Okay, so you see this parent run, child run, child run, child run. So this is how it is done. Let's look at it in our UI. So nested run. So now I have got parent run. This was the earlier one, and you have to understand that names can be duplicate as well. So if I expand this, click on this plus icon, you see this child run. Now, what would be the ideal scenario where we can potentially use this feature, where let's say one run can correspond to a larger feature, and then multiple nested runs can correspond to something more specific within that. One example that people often use this nested run feature is for hyperparameter tuning. So that is one of the use case that you can potentially go for. So yeah, so that is what I wanted to demo. I'll see you in the next video. So now that we understand how to log Scikit-Learn based models, it is right time to introduce a new MLflow concept, and that is MLflow model registry. From the name itself, it should be very clear, but at the same time, I feel that MLflow model registry name is not very appropriate. And I will tell you why I'm thinking this way, because when you think about registry, you often think and associate registry with a storage, right? But that's not the case with MLflow model registry. It is not a store, although we call it as a store, but it is just a store for metadata. Ultimately, your models will keep staying inside the artifact store, which for our situation is our local directory. Whereas what model registry essentially means is it keeps track of your model's lineage, versioning, and aliasing. So there are things that you would want to do with your best model, maybe deploy it into production, or maybe you would like to see which run produced it and things like that. That is enabled by MLflow model registry. So it essentially is a centralized model store, although there is no storage component in a model registry. It is just it just creates this registry using a YAML file. Okay, and that YAML file points back to the backend and artifact store. Okay, so let's see how can we register the model using Python or maybe UI as well. So let me go here and let's see. Let's assume that I want to register this model. The only thing that I need to do is I will come here. I will select the model. So I have to basically create a model first. Now, what exactly I'm doing? You might be confused here because we already have lots of models that we trained in our last discussion using auto logging and manual logging. But what exactly we are creating? We are essentially creating a registered model here. Let me go here. Let me come in models. You see, currently there are no registered models. Let us create one. Let us create best production model. So if I create it, there are certain things which will automatically be created for this model. One important thing which is its version. So if I come here, you see currently it is having no version because we did not associate any model to it. Okay, so let's see. Let's go in the experiments again. Let's come here. Let's come to the auto logging, and let's come to the let's come to the models. Now this model is from the logged models, not registered models. So if I click on it, now if I click on registered model, and if I click this drop down, I see this option best production model. If I register it, my model will be registered. And now if I check the version, it says version 1. But let me do one thing. Let me come into the experiment. Now let me go inside the logging, simple model, register model. Now if I select that same model, what will happen? Let's see what happens. You see, it has incremented it to the next version, which essentially means this is a very good tool when you are building and pushing models into production. So if I open this, you have got two versions, and I can click on various versions. So I can maybe click on version 1, and I can look at its schema. Now this schema is automatically inferred by its input and outputs. How does that work? Because it is created using MLflow. That is why it is able to, the MLflow is able to infer its input and output schema, essentially the shapes and all. Okay, now what I can do is I can come here, I can add tags to it, I can add aliases to it. Aliases would help when, let's say, I am deploying the model as HTTP based server. Their aliases might help. Okay, so for now, the basic idea that you have to take is you can register a already logged model, and that gives you some additional features such as versioning and lineage for the model. Okay, now the question is, can I do that via my code? Yes, we can. In fact, when you are logging the model, so let's say in auto logging you can't do it, but if let's say I am doing calling this sklearn.log model, inside here I can pass sk model and then name, some dummy name, and then I can pass something known as registered model name. The moment I pass something like this, now the moment I run this code, let's run this. Okay, let's say my model and registered model, and let's for the sake of it, let's use the same name here, and let's run this. Okay, I'm running this lecture 5 only, and let's see what happens. So we are also using its auto log facility, and we are also logging the model by default, manually, sorry. You see, registered model exists, hence it is creating a new version. So if you refresh it now, you have got version 3. I hope you are able to understand how model registration works. Okay, so I think that would be it for this video, because model registry in itself is not a very huge topic. But now in the next video, we will be taking up this model, and we will be trying to access it via HTTP based server. Okay, let's get started. And I think in the next session, I will also have to talk about model URI. Essentially, I think I can do it right away. So model URI is essentially a unique identifier that you can use to reference a registered model. Okay, and the way you do it, this is models / model name. Now here my model name is best production model, and then model version. That's it. So this is the model URI that you can essentially use when you have to, let's say, deploy a model. And in fact, we will be looking at how we can do that as well. We can also reference a model using as runs syntax. So I can have something like runs, the run name, and then there will be the model name. Okay, so let's Let us see these various examples in the next video where we deploy these models. Okay. Thank you so much. So in the last discussion, we talked about how to take your models which are logged, which are hidden inside a run, which are stored within the artifact store, and take those model and put it inside a separate store, which is essentially referring to the same thing, but now with some enhanced metadata. Registered models are just the same model, but with some additional metadata tags, which helps in organizational and operational aspects. In this video, we will quickly look at how to take those registered model, or any model for that matter, even those which are logged within the run, and deploy it using a HTTP based endpoint. You might be wondering or maybe worrying that I don't know about Flask or maybe a fast API. How can I do that? The answer is you don't need to know any of those things. How can you then run a HTTP based server? Just open a new terminal, activate your virtual environment and run this. MLflow provides a utility called model serve. Now after this serve, you need to provide some arguments. The first one is M for model. In the model, you want to specify the URI that we discussed in our last discussion. The URI follows this format: models, : /. Let's go to the registry and let's grab the model's name. So best production model, let's grab this and let's paste it here. And we also need to specify the version. So let's use the second version. After that, we need to use the port. Port, we can use anything. Let's use some random port. I don't know why, I don't know how I came up with this number, but yeah. But sometimes what happens is I use some random ports and there is already an existing service using that same exact port. And in that situation, MLflow will throw an error. Finally, there is this argument which you need to specify if you are not willing to serve this model using container based setup. So I'm specifying no conda. If I run this, it will it has basically started this process, and it has started a server on this URL. Now this URL by default exposes several endpoints such as invocation, health, etc. Let's try out this. Let's curl into it. Let me grab this URL first, Control C, and let me paste it here. If I hit enter, it says not found, but let's call it health. In health, it does not return anything, but it is not also giving us any error. There is one in particular endpoint, that is invocation. Invocations. Yes. You see, method not allowed. So it's saying this method is not allowed. Why? Let's see. 1 second. Let me expand this. Okay, it's saying 405. In the health, it said 200. Okay, but in this, it is saying not found. Why it is not able to find? Because invocation is the one that I must have misspelled it. Invocations. Why? Okay, let's pass the argument. I'm not getting why it is not accepting our request. Content type application JSON, and we also need to provide data. In the data, I'll wrap this data in here. Let's pass inputs. Inputs would be a list of all the rows that you want to get the prediction for. Yes, you see? Okay, so method was not allowed. Somehow, when we don't pass data, it simply does not return. But let's see. If I remove this 4 it will give this error that X has 3 features, but logistic regression expecting 4 features as input. So our model was trained. Now, where did we set up this? Let's look at this. When we created this data using make regression, if I recall correctly. Oh, no, load iris. So this is what we used, and inside here we have 4 features. That's why it is requesting for 4 features. Okay. So that's it. That's how you basically set up a HTTP based model server using your registered or logged models. Now, this is very simple actually, right? But this kind of setup is only ideal for real-time inferencing, or in ML system terminology, it is known as online inferencing, where you deploy this REST-based API into a Lambda function or maybe Azure functions, and then you start accepting some requests, and then you serve those requests on the go. Okay, but for the batch-based requirements, you might have to create a script and call load the model, and that batch setup, how we can do, we can load the model using sklearn's .load method. Let's try it out. Okay, so let me now create a new script maybe, and inside it I'll just import MLflow, and I'll say MLflow.load sklearn.load model. Inside here I need to specify model URI. So let's use this same model URI that we just deployed. 1 second. Okay, so this is the model URI that we basically chose. So let's grab this, and I'll say model URI, and inside here I can pass this, and what I will get in return is a MLflow model, which I can use for batch inferencing. Okay, let's run this script. Just 6. Okay, so you see it is printing logistic regression, and that's what our model is. Now we can use this model just like we would use a normal sklearn model. Okay, so this is how we load a already registered or logged model for our batch inferencing workloads. And for real-time inferencing, for online inferencing, we just spin up this nice looking server. I hope it is making sense. Hi everyone. In this video, we are going to be taking a little detour from our traditional ML, and we'll start talking about GenAI based MLOps experiment, or rather we should call them as GenAI Ops or LLM Ops. You can call it whatever you want, but the key thing is to master the fundamentals so that whatever the outside world calls it, you know what you have to do. Okay, so the first topic that we need to cover is how does GenAI Ops differ from traditional MLOps. Now in MLOps, there is this thing called machine learning model that gets replaced by prompts in LLM Ops, because essentially what you have to do is, just like models can be random, models can be can not be very deterministic, they are probabilistic. Just like that, prompts can also be probabilistic. It's very simplistic explanation, I know, but it gives you a clear difference between GenAI Ops and MLOps. So LLM Ops, in LLM Ops, we need a way to manage prompts, just like we had to manage models in the MLOps. Now, to manage models, MLflow provided you with the model registry, and you must be guessing it right. To manage prompts, MLflow is providing you with the prompt registry. So let me quickly start the MLflow server and show you what exactly I mean by that. So let's open Chrome and open this server. Okay, so you see these prompts. If I go here, you will see some prompts which already got created when I was playing with this concept in MLflow. But we can come here and we can create prompt. Okay, we can provide the name of the prompt. We can choose the type of the prompt, whether it is text based and chat based. And I'll show you what exactly both of these mean. I will provide the prompt. I will provide the commit message. So essentially what happens is you get to version your prompts. You can create multiple prompt versions. So suppose we are building a question and answering or frequently answered questions FAQ bot. Okay, we are building FAQ bot and we are trying to optimize and create the best prompts. So how can we go about it? So we have named this prompt as FAQ bot. Now under it we can basically define what is known as prompt template. Now that prompt template will be replaced by the actual variable that we need to inject within the prompt. But let's start with the text-based prompt and I'll tell you what chat-based prompt looks like. Or maybe I can show you. In chat-based, we can have, similar to how we call OpenAI's API, we can have various type of roles: user-based, system-based, and assistant-based. And for these roles, we can basically have different sort of, you can say, messages. Okay, so let's go with text-based prompt and let's write it down. Okay, so you are a helpful assistant who answers the provided question concisely and precisely. Okay, so this is the prompt, and now let us write that the question will be here, and here we will write the placeholder as suggested by MLflow. We will write question as the placeholder. Now later you will see how we can replace this question, but for now we are just creating prompts. We are not seeing how we will be basically loading this prompt and passing it to OpenAI or whatever LLM you are using. I'll use the commit message to basically track. So version 1. Okay, so let's create it. So we just added a new prompt and it is a version 1 prompt. Okay, all right, so it is a version 1 prompt. Now what is the next step? Next step would be to basically try out this prompt and evaluate it. We can evaluate it, or we can evaluate multiple prompt versions. I can create one more version of this prompt. So you see this same prompt appearing because I can edit it now. So I can say something like answer the question only in English. Second, answer should be under 3 sentences. Okay, and that there are more things we can add, and if I can create it, you will see version 2 is added. Okay, now I have the ability to compare prompts. So if I click on compare, automatically these two versions are selected and we see color highlighting of what is added in the version 2. If let's say I have got one more version, then I will get the ability to select one prompt for the comparison with the another one. Okay, so this is how MLflow is providing you with the prompt management, or rather I should say prompt registry, just like it provided you with the model registry. Now what you can do is you can create and load these prompts through Python SDK. You can actually, so what the process that I showed you from UI, you can replicate this exact process through the Python also, and I'll show you that in a moment. Okay, so now let's try to create a prompt just for the sake of it to show the demonstration. So I will create lecture 8.py and I'll create a new shell here. And here, let's import MLflow. And inside MLflow, let's define prompt version 1. Now this time I won't be touching this frequently asked questions bot prompt. I'll be creating a new prompt. So let's get started with that. So prompt version 1 would be, I will create a new line and I'll probably escape the first one. And then I'll write, you are a helpful, or maybe let me grab this entire thing because I should not be typing it right now. Okay. So yeah, so this is my prompt. Let me get rid of this. So this is my prompt version 1. Now what I can do is I can do something like MLflow.GenAI save. Let me type prompt. I think it was load prompt, not load, register prompt. Sorry, register prompt. So inside it, we have to pass name first. So name would be what? Just like this, I can have frequently answered question bot. Now, if I use this same exact name, what MLflow is going to do is it will register one more version. So that's why I will be. So it's just like MLflow models. I will be using first, and next we can provide the template. Template would be this string. Okay, and we can provide commit message here. Commit message, the way we provided message in the UI, we can provide it here also. Version 1 prompt. Okay. Now if I run this, we should be able to see our prompt in the prompts. So you see frequently answered question bot 1 that we just created, and we are seeing this prompt, right? Okay. So what is the next step? Next step is going to be loading the prompt. How can we load the prompt? Now, obviously, I want to get rid of this now. Okay. So let me maybe comment it out for now. Now, suppose you are working in an organization setting where maybe, I don't know, 100 of people are working on a project or working as a data scientist or GenAI specialist, and they are all trying out their own prompts, and prompt building is much more easier, I would say, than model building. So hence, prompt can be built not just by data scientists, but can be built by other folks, maybe product specialists or maybe managers. So there will be a lot of prompts appearing, and MLflow can provide a centralized place where all those prompts can go. Okay, and they don't need to do it through Python. They can create a prompt from here as well. Now, suppose you know a given prompt is best one performing. For now, let's assume that we know from our experience that given prompt is working best. Now, how can we go about actually loading the prompt? And finally, after loading the prompt, we should be able to use it also. When I say use it, I should be able to use that prompt and pass it in a LLM. And I'll show you that in a moment. So let's try to load this frequently answered questions bot using Python. So how can I do that? So I'll do something like MLflow dot GenAI dot load prompt. And inside here, I need to provide name or the URI. I can either provide the name, that is this, or URI. And URI follows just like models, it follows something like this. Prompts, the name of the prompt. So if I use the name here, and then version. Let's load the first version for now. After loading the prompt, what I can do is I can save it in a variable. Now let's try to print it out. How does it look like? Can you try to guess how will this prompt be looking like? Let's see. So if I run this, so this prompt is looking something like prompt version, name, version, and template is only given. Some characters of templates are displayed here. Now how can I actually use it? So what I can do is I can call prompt.format. Now inside this, I can provide all the placeholders that I have used here. So let's pass questions here. How is the weather like? Okay. So now what do you think will happen? Let's run this. What it will do is, it will take my prompt and it will inject this question variable that I passed. So prompt.format question. So you are a helpful assistant who answers the provided question concisely and precisely. Question is, how is the weather like? Now let's extend this, and let's register one more prompt version. So let me comment this out first. And this time I'll be using frequently answer bot 1, the original one, and in the prompt version 1, or maybe I can rename this to version 3. In place of question, I would want one additional variable passed here. So what can I pass? Username. Okay, user name. Okay, now what I can do is, first of all, I need to register this prompt. Let's register it first. Okay, if I reload this now, I will have this prompt, which also expects a username. Now let us comment out our prompt registration code, and let's uncomment the prompt loading code. So now, besides the question, we need to pass the username, but let's see what happens if we don't pass the username. Okay, it basically, okay, no, sorry, I think I need to change the version also, no? Okay, so it says this, that is missing variables. Now what I can do is, I have two ways to solve this. Either I can provide a user name. Let's provide Rahul. Okay, and let's run this. It should solve the issue, right? Or, so, and Rahul. Or what I can do is, I can get rid of this and I can do something like allow partial is equal to true. In that case also, this will solve the error. So here, okay, one second. Yeah, so in here what happens is, what you get now from the prompt is not the text, but a prompt version only. So it was not able to render it properly. Okay, so I hope you are able to see how we can load the prompt. But now let us see how we can actually use the prompt. That we will be seeing in the next video. So in this video, the purpose was to show you how prompt management works and how it is similar to model management that we already are familiar with from our earlier lectures. In the next video, we'll be talking about how to load the prompt and also use it with, let's say, OpenAI's API. Thank you so much. So in the last lecture, we looked at how we can manage prompts using MLflow. Now, what we are going to do is, we are going to use OpenAI to actually use the prompt in a real production setting. So first you need to basically make sure that your LLM's API is installed. So I'll install OpenAI's API, which is already installed. After that, you need to somehow save your environment variables, and in particular what the variable that we want to save here is called OpenAI API key. So this is the environment variable that you need to save in the environment. Now, how can you save it? There are multiple options. You can use export by coming here in the command prompt, but I like to load it. I don't want to modify my my computer's environment variable. So what I usually like to do is, I load the environment from this file called .env. Now this .env I won't be showing you in this video, but this contains a key called OpenAI API. What I can do is, I can use a Python package called .env. So from .env, I'll import load.env. Now what load.env does is, so when you call load.env, it will ask you for the path of your .env file, which exists in the same directory from where the script is going to be run. In that case, you don't need to provide the path. But after this, you can access your env files. But for that, you would need to import the OS package. So what happens is, when you run this script, a new process is run, and that process will have its own set of environment variables. And what this load.env does is, it will inject any environment variable that it sees in this .env into the current process environment variable. So I will get env OpenAI API key. Okay. And this will provide me the API key of the OpenAI. Now what I can do is, I can create a client. So let's import the OpenAI client from OpenAI, import OpenAI, and I'll import the client, which is going to take API key. So now my client is ready. So now that I have this client, I can use it to, ask questions. Now I will be using prompt version 1 that I had. Or maybe let's use 2, because 2 was the better prompt. Let's see. Let's go to UI. If I go, yeah. So this was the better prompt. Let's although I cannot objectively say that this prompt is better, because I'm only subjectively saying. How can I objectively say that a prompt is better prompt? Is by prompt evaluation. That is a separate topic which we can take care in some other discussions. But here, from visual look, the way humans interpret it, it's more detailed prompt. So it should give us the right answers. So let's go here and let's load the second version of the model. And I will now load the message. So I'll call prompt.format and I'll ask a question. Let's ask some question. What is or maybe I am not able to think about any question. So what exactly is the difference between sun and moon? I'm not sure. This is not a very good question. Okay, sun and moon. Okay, so now what I'll do is, I will also print this message just to see whether it is looking good or not. And let's run this. So you are a helpful assistant who answers this. What exactly is the difference between sun and moon? So we have the message. Now what we can do is, we can use the client.chat. And in fact, if you want to use responses API, that's also fine. It's better, I feel. But let's go with chat completions, because I feel the coverage of chat completion is more at this moment. People are moving towards it, but still it is not very prevalent. So I will be using a mini model, and then I will use messages, and inside messages I'll create a list where role would be user, and content would be my message that I created from the prompt. Now I will save this in response, and this response I can print. I can either print this response, or I can print the content. Let's first try to print the not message but response. Okay, so let's try to print what do we get. So it's taking some time, and we are getting the chat completion. So if you see, the sun is a massive star that produces light and heat through nuclear fusion, while the moon is a natural satellite that reflects sunlight. So I think pretty good, right? But if I have to get this text from here, so how can I do that? So what I can do is I can get my response dot choices. I'll get the first choice dot message dot content. Okay, so let's try to use that now in place of response. Okay, let's run this. Now currently remember that we are not logging these things like responses. That is a topic of separate discussion, because this the logging of both inputs and outputs in MLflow is going to be called as traces in MLflow, but we will be covering that in some later video when we start discussing the evaluation, prompt evaluation. So you see this is what is being returned by the OpenAI. So I hope it was clear. So in this video, we tried to look at how we can use the prompt. So this prompt registry is a centralized place to create and manage prompts. And from there, we can use and try out a bunch of prompts. Currently, we have not seen how to evaluate prompts. That we are going to see in next videos. Thank you, everyone. So far we know how to register a prompt within the prompt registry, MLflow prompt registry. And we also know how to load those prompts for our consumption. And also not just load, we can basically format those prompts, because essentially what we register in prompt registry is going to be a template, and then we can load those templates and use it within the LLM. Now, next thing is the way we evaluate models, we can also evaluate the prompt. So let's see how can we do that. So let me create a new file for this. And in this file, I'm going to keep all of this code. Let's keep this code. Okay, so we are going to be evaluating some prompts here. How can we do that? So let's go backwards. Let's first see the exact function from the MLflow that we use to start the evaluation process. So what happens is, when you run the evaluation process, a new run is created. When I say a new run is created, what it means is that run will be tied to one experiment. So similar to how we track a MLflow experiment, we can track a LLM based experiment. So let me start an experiment first of all. So I'll set an experiment. Maybe I'll say prompt evaluation. So currently, if you see, let me go to the server, and if I refresh it, and if I go into the experiments, we have all sorts of experiments, but we don't have prompt evaluation experiment. So let's run this file, or maybe I will comment most of this code, so that not this one also. So let's keep these things as they are. Python lecture 9.py. So after this, we will have experiment with the prompt evaluation does not exist, creating a new one. If you see this line. Now if I go inside here, you see prompt evaluation. Now within this prompt evaluation, so this MLflow view provides two different kinds of view. It can, so if I click on it, notice what happens. It will ask me what kind of experiment you are dealing with. You are dealing with machine learning based experiment or GenAI based experiment. Since this is going to be a GenAI based experiment, I'll confirm, because model based experiment, traditional machine learning based experiments are going to have different artifacts, different set of things than GenAI based experiment. As we discussed earlier, in GenAI based experiment, prompt is something similar to model. So it has different set of constructs than a machine learning based experiment. Let me confirm this. And if you see this view, and also to compare this, if you don't recall already, let me open a Scikit-Learn based experiment. This looks different, right? So this has runs, models, and our experiment, which is a GenAI based experiment, will be looking like this. It will have traces, sessions, data sets, evaluation runs. Currently, we don't have any evaluation run because we are going to create one. Okay, so after we do that, let's first of all look at the function that we use for the evaluation. So there is this function called evaluate. Now let's see what all things that we basically require to pass, because we are going to learn those in a backward like fashion. So first we see the evaluate function. So let's use the data. Okay, so we have data, we have scorers. Okay, and then we have predict function. Okay, so these three things would be required if you have to run the evaluation job. Now let's talk about the data first. What is a data? Now, similar to a traditional ML ops, if you have to evaluate that machine learning model, you need a data set, right? Similar to this, here also you would need a data. In the traditional machine learning, with your x and y's, you will also have to have the predicted value. That is how we can compute accuracy or F1 score, things like that. Here also we would need to have some sort of expected response. So this data will be a list, and this list will be essentially a list of, you can say, dictionaries, and each dictionary can have inputs. Okay, and let's talk about what input can contain. It will have expectations, because there are no. So basically expectations means what would be the right thing for this right answer for this kind of input. Okay, after expectation we can optionally have outputs as well, but since we are passing predict function, we are delegating this to the GenAI dot evaluate to basically call this function to generate output. So this list can contain as many test cases as you wish to basically include. In the inputs, you would like to have a key. Now, what sort of key should I have here? That depends. That depends on what sort of predict function that you will be having. So let's design the predict function first. What my predict function is going to do is, it is going to take a key. Okay, let's take a questions key, and this particular function is going to essentially return an output. Now what will be the output? Let's design that. Okay, so what we are going to do is, we will take this code. So essentially we will load the prompt first here. Okay, we will load the prompt first, and before even before even formatting the prompt, we will have to load the prompt, right? So from here I will load the second version of prompt. Okay, so I load the prompt, I format it, and I don't print it for now, and then I will call the OpenAI client API. Okay, so after I do that, let's see. After I do that, I basically assign the output. Output would be what? This, right? Okay, so now we have the predict function ready. Okay, so now I will write the predict function here. Okay, now let's come back to the data. In the inputs, I want to specify that key which is used in the predict function. So I will use the question key here, and in the question, let's ask the question here. Let's say what is the who invented maybe I don't know who invented telephone. Okay, now in the expectation, I will write something like expected response would be. So let's see who invented, because I don't know who invented. I think somebody, Berners-Lee, I don't know who invented telephone. Okay, Alexander Graham Bell. Okay, no, Alexander telephone. Okay, so I'll copy this and I'll write it here. Okay, so let's go with this first. Okay, so we have input, we have expectations, we have expected response. Now we can come here and we can write the data. Okay, so the only missing piece now is scorers. How can we basically create scorers? So this scorers would be a list of all the different type of scoring methodology that you would like to use to evaluate your answers. You can write custom scores, but for now what I'll do is I'll use the inbuilt MLflow's inbuilt correctness scorer. GenAI.scorer scorers dot correctness. Okay, so this is one scorer that it offers. Now this correctness scorer is a LLM based driven scorer. So let me pass it for now. And let's run this experiment. So now if I run it, what it will do is it will, under this experiment prompt evaluation, it will create a run. Let's run this and make sure it is successful. So you see this to disable. So currently you see this progress bar. So it is running some validation. So you see evaluation complete, metrics and evaluation results are logged. Let's go here and let's refresh it. We should be able to see this run. So if I click on it, we see this trace, and if I click on it, on the right I see some sort of correctness evaluation. We will look at what those things mean in the next video. I hope you are able to understand so far how to set up the evaluation with MLflow, but we will do a deep dive and look at other ways by which we can evaluate write these evaluations more in depth in next video. Thank you. So in the last video, we discussed about how to set up a prompt evaluation function using MLflow. Now in this video, we are going to deep dive into what exactly is the output of that evaluation. So what happens is that once that evaluation is complete, you get a new run. Inside that new run, you will get traces for each of the data inputs that you provided. So for the first data input, if you see, if I click on this trace, so you will get two things here on the left, inputs and outputs. Input would be the prompt. So you see, you are a helpful assistant, and then this is the exact question that was, one second, I think something is not right. One second. Okay, I think I did not use this question. So let's do one thing. Let's, in place of this, use this question and then run this evaluation again. So let me close this, and there will be new run that will get created after this. So you have to watch out this evaluation. So currently this evaluation is running. It takes some time because it takes help of LLM to basically do this correctness test. Okay. So if I refresh it, you see a new run is created. And if I click on it, you see, again, there are inputs and outputs. In the inputs, you see, you are a helpful assistant. All these things have been extracted from our prompt template, right? That we created earlier. That prompt template exists in the prompt registry if you can navigate there. So if I open this FAQ bot and I'm loading the second version, so this is the prompt template that we are loading. And we are replacing the question. So if I go back, I'm replacing the question, who invented telephone? And that question is coming from our evaluation data set. I can call this as eval data set, and this as eval metrics. Okay, so correctness is something that we are measuring. Now what is the output? Output is the output by the LLM model. Now we need to navigate to here. Alexander Graham Bell is credited with the inventing of telephone. Now why it was so concise? Because in the prompt we basically asked the LLM that you need to answer the question only in English. Answer should be under 3 sentences, and that is why it respected that. Now on the right you will see navigation, not navigation, on the right part of this screen you will see assessment. There are multiple assessment, only one assessment for now, correctness. I can expand this correction. It is saying yes, it means it is correct. The response that LLM has given, it is correct. How it is correct? It is basically following our expected response. Okay. So the claim states Alexander Graham Bell as the inventor of the telephone. The document explicitly states that this is credited with inventing the telephone. Now let's do something dubious here. Let me run this evaluation again, but here let me. So I'm kind of tricking the LLM to give the wrong answer, to basically fail this test. So let me do something like, let me write here, I don't know, Isaac Newton. Okay. So I'm doing this for fun, but let's see what happens. Okay, so who invented telephone? Isaac Newton. Now our evaluation is being run. So this is our expected response based on our ground truth. So ground truth itself is wrong, but let's see what happens. So if I refresh it, we have a new run and a new trace. And each trace will correspond to one data. So you see no. Why? Okay, let's expand this. Let's see the rationale. Questions ask, who invented the telephone? The document clearly states that telephone was invented by Graham Bell, which means this document states that telephone was invented by Graham Bell. Okay, and he was awarded. The claim, however, names Isaac Newton. Claim names as the Isaac Newton as the inventor, which is not supported or mentioned anywhere in the document. Therefore, the claim is not supported by the document. So this is the document that is returned by the LLM on the left, and this is the rationale that it is not correct based on the you can say based on the you can say based on the claim. Okay, so we are claiming that it is Isaac Newton who invented it. Okay, let's go back to that. Alexander Graham Bell. Okay, I hope you are able to understand what this correctness is doing. Now, there are some pretty cool things that you can do with only inbuilt things. So there are some ways by which you can build your own custom scorers that we can cover right now, but that maybe we will cover in the next video. But let me cover one more important you can say evaluation framework, that is Guideline. Okay, so there is one more thing that we can do, GenAI.scorer, I guess, .guidelines. Okay, in the guidelines, we can provide the guideline name. So suppose I create a guideline such as is professional, and I can instruct this guideline. So instructions, guidelines. So I can provide the guidelines. Again, these both correctness and guidelines will be LLM driven. So LLM is acting as a judge here. The answer should be professional. Or maybe let me trick this also, because in the prompt I'm saying it to give me answer in as precise and less than 1 word. But here guidelines I am saying should be professional and long. Maybe really long. Okay. So now it will fail, right? So the reason I am trying to cover this type of situation is I want to show you how this is working under the hood. Let's run this. And let's see how the output looks like. Okay, so let's refresh it and see. Okay, so this time a new run is created, and let's open the trace. So you see correctness this time is true. Correctness is true. Why? Because in the expected response, we clearly stated that Alexander Graham Bell is the expected response for this question. This is the claim. Now, is professional, why it is false? Let's look at the rationale. So it's saying the guideline states that the answer should be professional and really long. The provided response is indeed professional in tone. Okay, what is the response? This is the response. It is professional, but it is very brief and does not meet the criteria for being really long. Therefore, the guideline regarding length is not satisfied. So here in this particular assessment, we are able to see two different you can say correctness. We are able to evaluate this prompt using two different metrics, you can say. One is guideline and another is, now there are custom scorers that you can develop, which we will be looking at in next video. But I think this is going to be it for this video. But before I close out this video, I want to take your attention to one important feature of this MLflow, is that in this tab, if I come to the right, so within this tab, if you scroll to the right, you will see all the assessment and you will see this nice looking graph. Now, currently I have only one data, and that is why you are seeing only one trace, and corresponding to that trace, you are seeing it is passed, it is failed, and overall it is going to tell you what is the percentage of pass, what is the percentage of fail. Okay, for each of the assessment that you are doing. Suppose, hypothetically speaking, if you have got 100 test cases here, then there will be 100 traces here, and then it will be a real test of your prompt, like how many of those are correct, how many of those are professional, and things like that. Okay, so I can quickly show you what exactly I'm trying to say here. Okay, so I have just added three basically questions here. Maybe first question is, what is the capital of India? And let's write the answer as New Delhi. And then oldest, which is the oldest university in the world. Okay, and let's search for our oldest university in the world, and let's write that down. University of Bologna. Okay, so let's write it down as the expected response. Now we will be evaluating Control Z, University of what is happening? I think I'm not able to read. Control C, Control V. Okay, so now we have got three data points in our eval data set, and let's change it back to being professional only. Okay, and let's run this now. So now you will be able to see the true power of MLflow. So it will take some time because it is going to call LLM for three test cases. So if I now refresh it, so you will have a new run, and in the new run you will have three inputs, and if I scroll to the right, you will see one of them is failing. Which one is failing? Let's see. Our claim is that the oldest university is University of Bologna. I don't know where that university is, but let's see why it is failing. What is the output? It's saying University of Al-Qarin, founded in this. Okay, it is failing on the correctness. Why it is failing? Let's think it step by step. The claim states that University of is the oldest university. However, the document explicitly states that oldest. So you get the idea, right? But on the professional, so on the professional assessment is professional. All of them are professional. So this is how we evaluate prompts. But there are much more things that you can do. So for example, if you have to compare two different runs. So let's say I want to compare this salty run to the skillful run. So I'll select skillful, see what will happen. You will be able to side by side see which of your prompts. So it may happen that this run is corresponding to another prompt, and this run corresponds to some other prompt. So in this manner, you will be able to make a side by side comparison of both the prompts, and you can clearly, decisively say which prompt is scaling better, which prompt is doing better in correctness and in professionalism. And you can imagine, if you have got 100 of data sets and 100 of prompts, this can be really useful and handy thing. Okay, so thank you so much. In the next video, we will be seeing how to write custom scorers. So far, within our evaluation of prompts, we have been only using the inbuilt correctness and guidelines classes that are readily available that are provided by MLflow. Now let us write a custom scorer. Okay, so for writing a custom scorer, you need to basically create a decorator function. So let me first from GenAI import scorer. Okay, and let's create a function called custom scorer. Now this custom scorer can basically return certain things. Okay, it can either return a boolean, and it can take various things such as inputs, outputs, and expectations. There are other things such as traces also it can take, but for now let's go with this. We won't be needing inputs here, but let's use outputs and expectation. Okay, so suppose my custom scorer that I want to implement is trying to check for exact match. Okay, so I will say exact match, and what I'll say is I'll simply say check match is equal to if my outputs is going to be exactly equal to my expectation. Now expectation would be a dictionary, so I would need to extract the expected response. Okay, so I will just return this match one. Let's try to use this scorer. So I will plug this scorer after my guideline. So exact match, that's it. Okay, so exact match is going to take inputs. Now I'm not using inputs, that's not required. So let's now run this evaluation on the 3 data set, and I'm telling you this upfront that it will fail for all of these, because by default our prompt is asking for a generic answer. It is not strictly telling the model to return only the exact thing. Okay, let's run and try to see what do we get. So exact match missing 3 positional arguments. Okay, all right, why it is not okay, so we are getting 3 positional argument. Why do we need that? Why? Okay, if I provide the exact match just like this, I'm hoping that something is wrong here. Okay, let's see. We are not able to. Okay, so evaluation complete, but let's now go back to the run. Okay, so we have a new, and then in the trace, let me get rid of this first, please. Let's refresh it. Let's run it. Okay, so I have opened this in a new tab. In new tab, you can clearly see. So exact match, it is failing. Why it is failing? Let's look at that. So it says simply false. Why? Because we did not provide any rationale here. But if let's say you have to provide the rationale, you can use something known as a feedback class. So in MLflow, so from MLflow.entities, you can import a class called feedback, and instead of returning this match just like this, you can return a feedback class. Okay, the first argument of that feedback class will be this value, and then a second argument will be rational. Okay, let's come back here. So here we are correctly getting this answer. We are getting a professional answer, but on isMatch we are not getting anything. Okay, let's now do one thing. Let's add one more eval input to kind of see if we can get it to pass the test. So what is, I will ask it a very deterministic and simple answer. So what is 2 plus 2? Tell me just that, nothing else. And inside here I will try to just print 4. Now here is the issue, because in expected response we can have something like 4, or maybe we can have a list, but let's run it, because otherwise I will have to change all the expected responses. Let's see if we can get it to pass this test or not. Okay, so we have got 4. Okay, all right, let's refresh it. So we are getting this, and let's, okay, so even this is failing, but let's try to see what was the model's response. Okay, so it has basically given this rationale that 2 plus 2 is equal to 4, and in the test we are clearly saying checking whether output is exactly equal to expected response. But if I, let's say see, check it something like this. Control X, you can modify it if expected response in outputs, which essentially means that I'm saying outputs would be a string, and I want to check whether my expected response is in output or not. But let's try to see what happens. Okay, something happened, but let's see it in the UI. Okay, so we are able to pass all the tests. Okay, so let's open this trace in a new tab. In the new tab, what happens is, here if you notice, if I open any one of the trace and expand this exact match one, I'm able to see that this is passing, because here from the earlier exact match restriction, we expanded it to a very relaxed match, where I'm just checking whether the expected response is there in the outputs or not. Prompt engineering is everywhere right now, but most of the time we pick prompts by intuition, not by measurement. In this video, I want to show you how to evaluate prompts properly. We will take a real-world task, that is resume skill extraction, and I'll define some 3 prompts for the same input. Then using MLflow, we will systematically evaluate which prompt actually performs better using various metrics such as correctness, coverage, formatting rules, and even custom business level scorers. By the end of this video, you will have a clear framework to compare prompts for any LLM task, not by gut feeling but using reproducible evaluation. I hope you are excited. Let's get started. So before actually doing something and starting with anything, I would like to frame the problem and task clearly so that we both are on the same page. So first of all, the problem is that we have multiple prompts and we would like to choose one of them which is actually better for solving our specific task, right? Now LLM solves tasks via prompts. That is well known, right? So we have a task. It could be any task such as resume skill extraction or Q&A bot and things like that. We have an input and we have output A corresponding to prompt A, output B corresponding to prompt 2. Okay, so we have got multiple prompts and different outputs. So we would need a systematic way to choose the best one. That is why we need prompt evaluation. Now, what is the task that we are solving? The task that we are trying to solve is, we have a resume, and in a real business setting, maybe you are associated with a HR firm that might be dealing with millions of resumes, and that might want to extract skills from those resumes. So our task is to take the input as resume and convert that into a skills list. So essentially our input will be resume text and output would be clean list of skills. Okay, so we have a resume text as input. We will feed that text into LLM and prompts, and we'll get clean list of skills, that is output. And here these 2 arrows represent 2 different sets of skill sets that we could receive via 2 different prompts. Okay, so essentially what we want to do is we want to compare multiple prompts. Okay, so we will have a resume text input and we will have a prompt A. So maybe prompt A would be maybe something like shorter version of prompt, and then prompt B might be instructed to extract in a very strict manner and also provide us the structured output. And all of these prompts will correspond to one output, not one output, because if you run the same prompt again and again, you might be likely to receive different outputs. But the idea is that the more detailed the prompt would be, the likelihood of the output would be same, would be very high. Okay, now the next thing that we need to think about is, let's say I have got 4 prompts and I would like to understand which prompt is better. Like, how do we mathematically and objectively define that a given prompt is better? Okay, so we have various metrics, and we will be using MLflow inbuilt metrics and some of the also custom scorer based methods that are provided. So we have got things like correctness. Now, what is coverage? Coverage is nothing but a guideline based metric that we will be defining. We could have custom business logic. So all of these things we would be defining in the code that we will be writing in a moment. Okay. So we can have LLM based scorers. Essentially, LLM based scorers take your LLM output and the input, and it tries to, based on its capability of language and reasoning, it tries to understand the output generated by another LLM and give you a sense of semantic quality of how much the outputs are related to the input. Then we could have rule based scorer, in which we can take the output and we can apply some heuristic rules, such as maybe calculate the length of the output, or maybe split the text, split the output by comma and try to see how many skills we got. Okay. So essentially what we are doing is we are evaluating outputs here, not actually the model, or rather I should say we are evaluating prompts. So what are the scorers we are going to use? Although there are like a lot of scorers, we will be using correctness and guideline. Now all these must be looking very intimidating, but essentially what we will be doing is we will be using the inbuilt guidelines scorer by MLflow, and then there are other scorers that we will be writing from scratch, which would be called as custom scorers. Okay. All right. So essentially, what we want to do is from ad hoc testing to reproducible evaluation. That is the idea. We don't want to basically randomly say that this prompt was better. We want to show that this prompt was actually better. Okay. So that is the idea. So what I'll do is I'll just open my project folder. Now this is my project folder. I have already activated my virtual environment, and if you are new to this video, you might want to check out some of my older videos where I basically demonstrated how you can set up MLflow on your laptop and also how to get started with it. So I won't be showing all of that in this video. Okay, so let us first of all create a plan first of all. Okay, so I'll create a plan.txt file, and in this plan I will write down what would be the steps that we are going to follow in this video to set up this evaluation system. Okay, so first thing first, I want to have a resume. Now how can I get resumes? Okay, so you can basically go ahead and download some sample resumes from internet, but what I will do is I'll just use my own. So I have got my CV downloaded here on my system. If I have to show you that, so here it is my CV. So now what I'll do is I'll try to basically use this within my project. Okay, so the project is resume to skill extraction. So let's define some of the steps that we are going to follow. Okay, first would be we would be trying to create a data ingestion system. Although it's not a very sophisticated data ingestion system, this would also only include reading the file, reading the PDF, but this can be scaled to any number of PDFs that you might be having in your real world setting. So second step would be clean the PDF. Okay, so these two steps we will be following and demonstrating. So data ingestion is done. After that, we'll set up MLflow. Although MLflow is already installed, we just want to write down some introductory code that will allow us to basically log certain things. So we will be writing, we'll be creating an experiment, creating a new experiment. Then after creating the experiment, we would be importing some packages from MLflow. and then we want to create a eval dataset. You want to create a eval dataset, and I will tell you how that looks like, the format in which the eval dataset is written. After creating the eval dataset, we will be in the third step. We will be evaluating the eval dataset. Okay. Before that, the fourth step in the second step would be define a list of scorers. Okay. If applicable, write a custom scorer. Okay, so this would be the framework that we will be coming back to during this video. So let's get started, and let's quickly start with the project. Okay, so I'll say project1.py, and in this project, first I want to create this pipeline quickly. I don't want to spend too much time on you can say cleaning the dataset, but let's quickly get it sorted. So I will import the PyPDF module, and from PyPDF module I'll create a reader, and this reader will be essentially a PDF reader, and here I want to pass the stream of the PDF. So let me show look at the path of my PDF. Users, I should be having a path, users, and then Rahul, and then desktop, and then I got one CV here. So let me list down this directory. Okay, so I've got this PDF file here. So I will just grab this. Okay, and after this I'll append this name. Okay, so after getting this reader, I'll loop through all the pages. For page in, reader.pages, and what I'll do is I'll define a I'll define a resume text variable here, which will be an empty string, and I'll just append to it all the pages. So page.extract text. Now let's quickly look at how does this resume text looks like. Print resume text. I'll print the first 100 characters maybe. So let's print it out. Python project1. It says reader dot object is not callable. Why it is saying that? Because we did not have to do this. Okay, you see this? It is loaded now, but it is very messy right now. There are a lot of unnecessary characters, so we would like to solve that first. Let me import RD package, and let me define a clean text function really quickly. This will take a text and return a text. So first we want to lower the text, and after lowering the text, I'll just return save this in text. And after lowering the text, the next thing that I want to do is I want to substitute all the not allowed characters. So what I want to do is I want to take my text, and I would like to substitute what? I would like to substitute, so anything that is not a allowed character, I would like to substitute it with space, and I would like to apply this to text. Now what is my pattern? My pattern would be starting with R, and the pattern would be something like I don't want anything besides A to Z, and also space. So I want to keep space as the special character, and the reason I'm not keeping the uppercase A and Z, because I have already lowered the text. Okay, now let's try to return this text and let's see what happens. Although it's not complete yet, but let's see what is happening. So I would like to say cleaned resume text would be clean text, and I'll pass this resume text, and let's see how does it look like. So I would just Control C, Control V, and here I want to print the clean resume text. Okay, let's try to print that. If you see, there is not much difference right now. The only difference that I see is that objective has been lowered to lowercase. Now, how can I just remove these characters? Because there are some extra spaces here. So I want to get rid of that. So what I'll do is I'll apply one more substitution. And this time the pattern would be, I want to remove any space which is occurring more than once with one space. Okay. And I want to apply it to text. Now you will see a drastic difference. So let me run this now. If you see, this one was the uncleaned version and this one is the cleaned version. So you see this? Okay. So now it is making sense. Now we have the data ingestion pipeline ready. Let me uncomment this print statements. Although in your real world settings, what will happen is you would be having separate scripts for taking care of, all the things. You might be having a separate Python script to handle the data ingestion pipeline, separate Python script to set up the experiments and all. Okay, so I hope it makes sense. But for now, let's keep everything in this project 1.py file, and then we can take a look at how we can basically refactor this code into separate scripts. Okay. So now the next, let's look at the plan. So we have completed the first step. Now we need to set up MLflow. So let us do that. So I will be starting importing MLflow from here. So first, to set up the experiment, what I need to do is I just need to call this method called set experiment, and here I will just name it as resume skills extraction prompt evaluation. Now what happens is, if you are new to MLflow, then you might be interested in knowing how does this experiment work. So there is this experiment which is at the top, and then within experiment you have various kind of runs. Each run is essentially used for doing some sort of hypothesis testing, you can say. So this is a prompt evaluation experiment. So within that we can have several experiments to try out, several runs to try out different things. Okay, so we have set up the experiment. Now at this point, if I run this, so first let me start the MLflow server. After starting the MLflow server, I can come on browser and can go to this URL to look at this. If I go inside the experiment, so we have got already some experiment, because this server has been set up as part of the YouTube playlist that we already did on MLflow. So we have already got several experiments which are currently there. Now what we can do is we can open a new terminal and we can run this script again, and this time what will happen is, one second, it will create this experiment, because this experiment does not exist right now. Okay, so I'll run this project 1.py. So it's saying cannot set a deleted experiment as an you can restore the experiment or permanently delete. Oh, I see. So let me prompt evaluation new. Okay, let me write it as this, and this time it has created the experiment. So if I refresh it, so we have got one experiment. Now it asks me what type of experiment this is, because we are evaluating GenAI based models. We will be choosing GenAI apps and agents. Okay, so we have got this. You can come here on the evaluation runs. Currently we don't see any evaluation run because we did not run it at this point. So let's set up other things. So in the plan, we have set up the experiment. Now let's import some of the required MLflow packages. Okay, so what do I want to do? So I think I should have also in the plan written one step to basically set up OpenAI or any LLM, set up any LLM. Okay, so let's come to that. Let's come back to the project 1.py, and then let's import some packages. So I would like to import from GenAI.scorers. So we have to use two inbuilt scorers that are available by that are made available by MLflow. The first one is correctness and the second one is guidelines. Okay. And then we will also be defining our own custom scorer. For that, we need to import a decorator called scorer. Okay. So this is it. And I think there is one more thing that we could import, although I'm not sure how often we are going to use it, but let's import it. It is called feedback class. When we write a custom scorer, we can either return a boolean or we can return a detailed output with rationale of the decisions using the feedback class. Okay, so after this, I would like to create my eval dataset. So I will like to create my eval dataset. Now this eval dataset, will be a list of dictionaries. Each dictionary must have keys such as inputs. Input will be a dictionary. It could also have outputs. Now there are two options with you here. You can either create output within here, or you can define a prediction function which will actually interface with any LLM of your choice, maybe OpenAI's LLM or Gemini's, but that's your choice. We will be setting up OpenAI, so we don't have to pass this outputs. Otherwise, we would have to pass the actual output that you want to evaluate. Okay, so I would like to just take inputs here for now, and I would like to also create expectations. Now expectations would be, you can say, what are the expectations for this question. So whatever your input is, you want to understand what would be the expectation from that. Okay, so I will have a question here, and this question will be something, but let's define the expectations first. Expected response. So in the expected response, we have to define what is the expected response for this question. Okay, so now what we need to do is, why it is giving us, okay, I think I should have done this. Okay, so now this is the format that our eval dataset will be having. Okay, so in the expected response, what we can do is, we can write down what I would like to do, or what I can do is I can also define other keys here in the expected. Maybe something like skills. I can define list of skills that I would like to capture for a given resume. So now I can say something like in the question, and essentially this question is nothing but cleaned resume text. Now why I'm saying this is nothing but clean resume text, and in place of key I should have just added here clean resume text. Okay, now I need to define this expected response in a moment, but before that I would like to define a predict function. Now what this predict function is going to do is, it is going to take this clean resume text, and you have to name it exactly the way you defined it in inputs, and it would return the response. Okay, we would be defining the response in a moment. So what is going to be the response, and response should be a string format. So let me explicitly mention it. So it should be in a response. So essentially, either you can so maybe let's do one thing. Let's for now define the response as maybe Python, ML. Just for the sake of simplicity for now. I'm not setting up OpenAI's API for now. Just use this. Okay, so Python ML, let's expand this a bit. Maybe, I don't know, Scikit-Learn and linear regression, or maybe, I don't know, machine learning. Okay, now after this, so this is my response. So I am assuming that this will be coming from where? From the LLM. Now this would be my expected response. Okay. Okay. So the idea is that in here you will have a code to basically use this clean resume text. For now I am hard coding the response, but this is how it works. Okay. All right. So now what we need to do is we need to basically set up the scorers. Let's set up scorers. Scorers will be a list of scorers. So first is correctness. So correctness won't be taking any argument, because correctness is essentially an LLM based correctness measure. And what it will do is it will use the any setup LLM that you have available in your local system. Okay, then we have guidelines. Again, guidelines is also a LLM based scorer. In the guidelines, let's create a coverage based guidelines. Okay, coverage based guidelines. So I'm naming this guideline as coverage, and then we will be defining guidelines. So what exactly? So these will be human readable instructions for these guidelines. Are all the skills captured? Okay, so this is the guidelines job to tell us whether all the skills are captured or not. Finally, we will have a custom based scorer. So here custom based scorer may, let's assume we are writing one scorer called minimum 5 skills. Okay, now this scorer is something that we need to define. So let's define it right now. Define scorer, and here I can write scorer decorator. That's how we can call it. Okay, now this minimum skills minimum 5 skills decorator function, it has to accept some arguments, and the names are very restrictive. You cannot name the argument anything. So you need to pass only inputs, outputs. You could pass only inputs, outputs, and expectations. Nothing else you can pass. And what will be the value of inputs? Inputs will be exactly like this. This will be the dictionary out. Or in fact, I can even show you by printing it right now. 1 second. So let me show you these 3 by printing. So what will be the inputs? Inputs will be exactly this. And what will be the outputs? Output will be this returned string. And what will be the expectation? This will be the expectation. So the idea is that you can take these inputs, outputs, and expectation within this minimum 5 skills function, and you can do anything with it. When I say anything, essentially you have to return some boolean or some feedback based response. So you can return a feedback, also you can return a boolean. So for now, let's assume that it is passing. So minimum 5 skills are happening. We have to write the logic here within this function, but for now we are not writing logic even in predict function and also in minimum 5 skills. So now we are ready to run this, but we just defined this scorer. How are we going to evaluate on eval dataset? That's the final step. So we will call MLflow.GenAI.evaluate. This evaluate will take a data, and data will be eval data. So we defined the eval data, and it should be in this format only. So let's define eval dataset. And then after eval dataset, we need to pass predict function. So we have already defined our predict function. Okay. And finally, we need to define a scorer. Now, right now, if I run this, it would be failing. Why? Because this correctness works on LLM. But let's try it out and let's see what happens. Okay. Okay. So Python project1.py. So we have already set up one experiment. Where is the experiment? Yeah, so this is the experiment. So this will actually create a log, and that log will be, so what is happening? So we are printing it here, right? So what is happening is input is coming from here. You see clean resume text. This is how we define input. Clean resume text, and clean resume text is a very long text. Okay, after that, what do we have? After that, we would be having outputs. What is the output? Output we return from here. And we should be having outputs here, right? So this is the output. And then we have expected response. This is the, so finally we are printing expectations. Expectations would be, this is the expected response. For now, skills is just empty. Okay. All right. And then evaluation is complete. Now let's see what happens. Currently, you see correctness and guidelines did not throw any error. But let's see, what do we see here? We see a run name. If we click on it and if we look at it, so this particular thing is called as trace. So this is a run within this experiment. This is a run and this is a trace. And if you open a trace, in trace, if you see, this was my input and this was my output, right? Okay, makes sense. On the right, if you come, correctness is throwing an error here. What is the error? Let's expand this. The error is that OpenAI's API key is not available. That we need to figure it out right now. Okay, so that was the step, that is set up any LLM. And in fact, you are not restricted to using only OpenAI, but essentially you can use any LLM that you might be familiar and comfortable with. Okay, so let's set up the LLM. Now for LLM, I have created this .env file that you see on my left. This .env file contains a key called OpenAI API. Now I will be loading that .env file in my environment during the run of this script. So I will say from .env import load.env, and let's call the load.env. So what happens is this load.env expects a .env file in a given path. So I can pass a path here, or I can just leave it empty. Then in that case, load.env will look for .env file in the current directory. That is what will happen for now. And what it will do is so when we run this Python script, it creates a new process, and each process have its own set of environment variables. And what this load.env would do is it will just inject any variable that are there in .env into this. Now after this line, what we can do is we can import OS and we can load the OpenAI's key. Although we don't have to load it, because essentially the correctness and guidelines metric will be utilizing those automatically using their backend code. But let's try it out. os.get env, and I can call OpenAI API key, and we need to define it just like the way they are expecting. So you see, they are expecting just like this, and I have defined it. I won't be opening this because obviously this contains my API key, but you get the idea. So now I have got this API key. I'm defining it in variable, but I did not have to because I already loaded it, and these correctness and guidelines should be able to take it. Now this time it will take some time. And also, now that you have got this idea of inputs outputs, I'm just commenting it out. And let me run this project again. And this time it will take some time, because this time it will actually making the OpenAI API call using the OpenAI API key that we configured. So you see, evaluation has started and it is taking some time, right? Because it actually went ahead and ran the OpenAI query. Okay, so now refresh it, and we will see one more run. Let's click on it, and we see one more trace. And if I click on it, you see this time correctness and was yes. What does that mean? So if I expand this, now what will happen is it will try to look at your inputs. It will look at your inputs. Not inputs, but outputs. And it will look at the expectations defined here, and it will try to compare those by the LLM. So it says, let's think step by step. The document clearly mentions Python multiple times as a tool used in various projects and roles. It also references ML extensively through experience with machine, things like that. So overall, all components of the claim, this are directly supported by the document. Okay. Currently, if you notice, I have not set up any prompt yet. I just loaded the clean resume text as it is. I did not tell the LLM to do a certain thing, and in the predict function I'm just returning the response as it is. Okay, so there is no prompt evaluation which is happening right now. So the next step would be, in fact I should have also added that here to define some prompts. So define some prompts, and we will be doing that from the portal. We can do it from code also. If you want to know, you can check out my video on how to register prompts in MLflow. But for now, let's do one thing. Let's come here in the prompts, and let's create a new prompt. Okay, so I'll create a prompt, and in this prompt, what I'll do is I'll define resume skill extraction prompt. Okay, and here I will just write, you are an intelligent assistant helping the user extracting skills from the resume text. Okay, and here I'm writing a placeholder for resume text. Let's see how have I defined it, or maybe I can say clean resume text. Okay, so here is the resume. Okay, so here is the resume. Extract all the skills. So this is my first version of prompt. So I'll just name it as version 1 and I'll create it. So now my prompt is ready. Let's create another version. So create prompt version. Now from here what I can do is I can edit it. I can say the output should be in this format. So how do I want the format to be? I want the format to be in a JSON format, something like this. Skills, and skills would be a list of skills, and I can add comment list of skills. Okay, the output should be strictly in the above JSON format. Okay, so let's create another prompt version. So now we have got 2 prompt versions ready. Now let's do one thing. Let's run the evaluation. So how am I going to do that? So what I'll do is I'll define prompt versions. So versions. So I want to load 2 versions. So I want to evaluate 2 versions. So I'll loop through it. So for version in versions, and let's rename it as versions. Okay. So I'll load the prompt. Prompt is equal to prompt would be MLflow.GenAI.load prompt. And in here I want to pass the URI. So it would be prompts and the prompt name. So this is the prompt name and prompt version. So I want to write a placeholder of V here. That is why I need to have it as format string. So now I have the prompt loaded. Now I would like to format it. So I would like to write it as formatted prompt. Prompt.format, and in here I can pass my this what was the one second clean resume text. So I can pass this variable in the format as the clean resume text. So how did I define it? Clean resume text. So now if I for now just print the formatted prompt, let's see how it looks like. So for that I don't want to evaluate this for now. I would just like to see the prompt for now. Let's run it. Okay, so we have got 2 prompts here. In one case it says extract all skills. Why? Because if I see the first prompt, it says extract all skills. In the second prompt, it gives a detailed instruction into how would I like the extraction to happen. Okay, let's see how can we use it now. So I would just get rid of this. Okay, now in the formatted prompt, now I would like to grab this eval dataset here. Okay, so one second, Control Z. So this was my clean resume text, but now I can replace this with my formatted prompt. Okay, so I'm loading the prompt. I'm creating a new eval dataset for each of the version, and then I can call this. Okay, but for now it's not done yet because we did not define the predict function here. So predict function is currently using the clean resume text, and it is just responding with this response, this hard-coded response. So how can I change this response to load from the prompt, to load from the actual prompt? So how can I do that? So what I can do is possibly I can define the OpenAI's interface within here. For that, we need to import OpenAI also. So from OpenAI, import OpenAI, and then in the OpenAI, what I want to do is I want to create a client. API key would be API key. And here I want to create a new response, which is going to be client.chat.completion.create. And here I can define the model GPT-4o mini. Let's go with that. And let's write the messages. I can write the messages, and the messages would be role would be user, and content would be clean resume text. Okay, now I don't want this clean resume text here. I want this clean resume text to match the eval datasets clean resume text. Okay, because this is what will be used here, formatted prompt in place of that. Okay, and in place of response, I want to return choices.message.content. Okay, so this is how we can get this. So after this, we pass the eval dataset, which is going to take the formatted prompt that we are passing, that we are essentially passing here as well. So this formatted prompt, and this is going to be the expected response. For now, let's don't write the this minimum 5 skills function. Let's see whether this is getting run successfully or not. Let's run this. Python project 1. So it is running, but I don't see the evaluation line. Okay, yeah. So now we see the evaluation one. So it will run this evaluation, I guess, 2 times because we are running this in a loop. But surprisingly, it is taking, yeah. So first evaluation is complete. It will run one more evaluation. Essentially, we are running 2 evaluation for 2 different prompts, and I'll show you how you can actually compare the 2 results in a moment. Okay, so now both of our evaluations are complete. Now if I refresh it by going in the experiments, so you see there are 2 experiments which are basically used here. So let's look at the first one. So first one, in the input, we were using the extract all skill. So it is a very simplistic prompt, the prompt version 1. In the correctness, we see the claim mentions this, the document exactly list. Okay, so this is right. So correctness is getting passed. Coverage. In the coverage, how did we define coverage? So coverage was defined via the guidelines class. That is, are all skills captured? So it says yes, the sole guideline provided are all the skills captured. The input is a detailed resume text containing numerous skills across programming languages, blah blah blah, and then comparing the detailed resume text with the extracted skills, the response captures all explicitly mentioned. So what is the response? Let's see the response once. So you see the output is so what the OpenAI is doing, it is extracting all the skills, and it is not adhering to the structure that we provided in the version 2. Let's look at the version 2 trace. In the version 2 trace, let's look at the output ones. Yes, you see in the outputs, we are basically getting a, you can say, JSON with a skills, and minimum 5 skills is getting passed, coverage is getting passed. In the minimum 5 skills, for now we are just returning the true. We can fix that in a moment, but this is how it is looking like. Okay, So now, how can I say clearly that minimum 5 skills? So let's see here. So let's write minimum 5 skills again. So what I want to do is I want to take my outputs. So outputs would be a string, and I would like to try to load it as JSON. So maybe what I can do is I can define another scorer, which will be something like is JSON. Okay. And it would take outputs, and if it would try to load, so import JSON try JSON dot loads outputs. So if it is successful, it will return true here. Okay. And if there is some error, we will return false here. Okay. So and I can also add this is JSON evaluation here, is JSON based scorer here. Now in the minimum 5 skills, what I can do is, first I would like to do the same exact thing here. Why? Because I can count minimum 5 skills only when I can structurally load this, right? So I can say if we have the skills JSON, if we don't have we are not able to load it, then we will return false, and I can also get rid of this. Okay. Yeah. So after this skills JSON, I'll extract the skills. So I can say something like if skills JSON dot get get skills, if we have a key called skills, we will return something like, maybe for now let's keep as true, else return false. And then if we have the skills, I would like to count the length. So if length of skills JSON is greater than 5, then I would like to return it as true. Otherwise, I would like to return it as false. So you are able to see the picture, right? So first we try to load the JSON. If we don't have the JSON, we return false. If we have a skills, otherwise we return this. I can also get rid of this now. And if we have a skills and the skills is having a length of greater than 5, then also we do this. Okay. So this is how we basically create these two custom scorers, that is minimum 5 skills and is JSON. Now let us run the evaluation once again. Because in real world projects, you just don't want the output to be correct and follow the guideline, but also you want the output to be following the coverage part and also the structure part. Okay, so let's run this one last time, and let's see how our prompts are performing, and then I'll also show you how you can actually compare them side by side. Let's wait for a couple of seconds for them to complete. Currently first prompt is getting evaluated. For me, meanwhile, I'll just come here. I'll show you how you basically evaluate it. Come here in the evaluation run, open this. So if you see on the right, you see this assessments here, and if you have to compare it, so casual do run, you want to compare with funny one. Okay, let's see. Okay, I think one evaluation is completed. Let's see, 1 second. Okay, so we have the evaluations ready. So let's refresh it. We have 2 evaluations. So first is honorable, that is with the second prompt. So we are seeing correctness and coverage here. So let's load this. Let's view this in a separate page, and let's try to see it. So you see, is JSON false? It is not JSON. Even with the second prompt, minimum 5 skills false. Why? I don't know yet, because we need to dig into why it basically is not showing us the result. But let's try to see the second one. Honorable cat is done. This one here also we are not getting the results. Why it is happening? 1 second. output is okay. So this is expected because we are not getting a JSON based output, but here we should be having a JSON based output. Are we getting as output anything else also? Okay, so I think to be able to see that why it is failing, we need to debug the output, but you are able to see the overall picture, right? The overall picture is that this is how we define our custom scorers, and this is how the prompt evaluation works. And to compare the prompts side by side, the way it works is we can come here and we can compare it to one run, and then these will appear like this. Okay. I see, because JSON is being returned here, and that is why it is not able to parse it clearly. Oh, I see. Okay, but anyways, I think this video is already 50 minutes long. I would like to stop right here, but you got the overall idea. The idea was to show you how you can use MLflow to structurally and in a reproducible manner compare your prompts using both inbuilt scorers and also the custom scorers. Please let me know if you have any feedback. I would like to cover them in next set of videos that I prepare. Thank you so much. Hello everyone. In this video, we are going to be looking at MLflow's AI gateway feature. We have already seen prompt management and model management using MLflow, but now we will be looking at how you can manage your LLMs, or rather LLM providers, in a much more efficient and effective manner. With this AI gateway, you can create several API keys, and you can securely use those API keys within the endpoints. And in endpoints, you can have several different providers, several different models. You can also have traffic splitting the way you can see on your screen. I am basically using OpenAI's GPT-4o model and Google Gemini's Gemini 2.5 Flash model, and I am splitting 50% traffic to it. And apart from all of these, you also get one common interface to call these application. If I can show you, so you can see I'm getting this URL which I can use irrespective or without knowing how the internals of Gemini or OpenAI's calling work. Okay, so I feel this is much more powerful than individually coding the wrappers, or maybe you using the wrappers providers SDK in your code. Okay, so if you want to if you are excited about this video, then please continue. Okay, thank you so much. So first of all, let us quickly set up our virtual environment. So I will create a virtual environment really quickly using the Ven package, and after this, let's activate this virtual environment. After activating this, I would like to install the MLflow package. Now I want to install this package with GenAI extension. So I will specify that. Okay, it will take some time, although I did install it previously, so it will be using mostly the cached versions of the packages. So let it complete. Meanwhile, what we want to do is we want to set up two different models from two different providers into the API gateway. So let's arrange the API keys for that. For one of the projects, I am going to be using the OpenAI, and another one I will be using the Gemini's API key. For Gemini API key, AI Studio is a great source, and from there you can get API keys for free without even giving your credit cards. So I will come here on the bottom left and I'll click on Get API key, and I can click on Create API key. I need to select a project. You can select any project, or you can create a project. It's free of cost. And then I will hit on the Create API key. After that, I'll just copy this key, and for now, let me save it in a text file. Okay, API keys dot maybe text. Okay, so this is my Gemini's API key, and then there is one more API key for my OpenAI model. Okay, so now that we have the packages installed and API keys set up, now we want to start the MLflow server, because that's where we are going to be creating endpoints and API key. I'll tell you what endpoints are in a moment. So I'll do MLflow server, and I'll specify the port. I'll specify 5000 or any port which is not in use. Currently for me, 5000 is not in use. So you want to make sure that 5000 is something that you can possibly use. So let us wait for the server to spin up. It will create a database file, because currently I'm on my local environment. The database file will be created here. So you see this mlflow.db file. So this is a simple SQLite database which will be used by MLflow. Now after this, I want to basically navigate to my browser, and I want to go to this URL called 127, which is called home, and at this route. If I hit enter, you will see this interface. If you navigate to experiments, models, all these things are just empty, but we want to go to AI gateway here. Now currently MLflow is developing this feature so it's not I would say matured, but two features which I personally have used is the managing API keys and endpoints. Now how do they work? I'll tell you. So endpoints is, you can say, a centralized place where you can have multiple model LLM providers which you can register, and you can split your traffic between those, and in this manner you can do pretty cool things like looking at which model is performing best for your use case. Okay, so I'll show you how to create endpoints, but let me first show you how to register API keys. So I will be registering two API keys. So let me create first API key first. So it is loading provider. So let's create a API key for OpenAI. I'll say my API key OpenAI. So you might be having a situation where you are into in a large organization where multiple different API keys exist within OpenAI, so you can manage all those sort of things here. So let me grab my OpenAI's API key here, and then come here, and I'll just paste it. Now I don't need to provide a base URL, so I'll just create API key. Now I will come here again, and this time I'll use Gemini, and here I'll say my API key Gemini, and I'll grab my Gemini key that we grabbed from the AI Studio, and I'll paste here and create API key. So now we have got these two API keys which we can use and load. So there are interesting things that you can do in your Python script, so it's like your you can say .env file. Now you no longer need to load from .env, you can load from here also. Although I know it's not a very exciting use case, but let's go to endpoints, and you will see where AI gateway, MLflow's AI gateway can shine. So I will come here and create an endpoint. So I need to basically specify the name of the endpoint. Now you can think of endpoint as a container. Now, by any chance, if you have worked with Azure endpoints, real-time endpoints, or maybe SageMaker endpoints, you would understand what I'm trying to say here. Endpoints are a way to have different models deployed within the endpoints, and here AI gateway's endpoint is very similar to that. Under one endpoint, you can have several different LLM models, and it's just a wrapper. But the nice thing is that now that we have got thousands of LLM models, you don't have to manage you can say the interface between all those different LLM providers. You can remember and recall only one interface, and that is MLflow's interface, and you can just forget about it. Now you might be wondering, like, there are other wrappers also available. For example, LangChain also provides such kind of functionality. You would want to answer this question, that why MLflow? Now to this question, I would probably say that MLflow has certain other features, for example, experimentation, prompt management, model management, which your other tool might not be having. So it can be integrated into your AI experimentation and prompt evaluation and all workflows quite neatly. So that is one of the plus point of this tool over others. Okay, so every tool has their merits and demerits, and we can create a separate video covering that only. So when I provide the endpoint's name, why do I have to provide model? Because you can't have an empty endpoint. You need to provide at least one model. Okay, so what I'll do is I'll come here and I'll say, let's say my chatbot endpoint. I'll say chatbot endpoint. Okay, now this chatbot endpoint can have multiple models. Okay, now let's start with OpenAI's model. So I'll say OpenAI. Now here in the models, I need to select which model I will be using. I'll be using one of the cheapest models. So I'll come here. 4o mini is the one that I feel at this moment is the most cost like friendly in terms of, so and you not only get model names but also what features they support, like GPT-4o mini supports tools, caching and structured outputs, and it has maximum input token of 128k, and it has cost and input and output tokens costing. So you can see you have got $0.15 for per million input token and $0.6 for per million output tokens. So I will select this GPT-4o mini. Now I can create a new API key or use an existing one. Okay, so since I already have a API key, so I can select that one. So I will automatically it will display only the OpenAI's API key. And you might recall that we created two API keys, but Gemini one are not being displayed here. So I'll select this, and now I can go ahead and create this. So it does certain things, like it will mask your API key so that those will not be displayed here. Okay, so I'll go ahead and create this. The moment I create this, now if I go inside the endpoint, I'll get this chatbot endpoint, and if I open this, you see there is this thing called priority. Now what is this priority? Now priority lists down all the models that you want to basically use. Okay, so currently this priority has only one model, and there is one more priority, and this priority is basically a fallback. Suppose you have two your API keys expire, or maybe because of rate limiting a given endpoint a given model fails. So in that case your priority 2 will be executed. You can add a fallback, and the process of adding fallback is just like previous. Now within the priority 1, I can have a traffic splitting. So let's do one thing. Let's create one more model within this first one, and here in the in the model 2, what I'll do is I'll select this time Gemini, and here let's use Gemini's 2.5 flash, and we have got costing here as well. So I'll just and here the maximum input tokens are massive. 1 million input tokens we can have. I've selected, I can use the existing API key, and I can use this Gemini's API key, and I can also specify the weight. Weight would mean that how much traffic splitting I want to do. Now MLflow will handle all the load balancing between these two models. Okay, so what I can do is I can have something like I want my 50% of the traffic to go here, and I want 50% traffic to be basically handled by OpenAI's model. Now here you can think of this from a very broader perspective. If you want to evaluate a given model in a real production scenario, you can possibly have a setup where you want to evaluate each and every output, and in fact you can connect this directly with your experimentation. And in experimentation, what you can do is you can tie these, you can add tags to each run, each trace, and that tag would tell you which basically model was used to generate this output, and then you can basically evaluate which of the model is being is correctly giving you the output. So now what we can do is we can simply save these changes. Okay, so now our endpoint is ready. Now we have got two providers here, and also we have got two providers, and we have got use by, and all these tags are there. But what I want to do is I want to use this model, right? How can I use it? So I can come here on the top right, and I can click on this use. So MLflow is providing you with this URL. Since currently my server is running on this one on locally, so I'm getting this URL /gateway and then name of my endpoint. This is the name, MLflow invocation. Now you see, I am not interfacing with OpenAI or Gemini anymore. Now I am interfacing with directly the MLflow's URL, and that URL when I hit, it will take care of calling the appropriate model. Okay, let's copy this, and let's come here to the terminal, and let's open a new terminal. So what I'll do is I'll just paste the curl request curl command here, and I'll try to hit enter. I'll wait for some time, and it should give me the response, and it is giving me the response. If you see, it used Gemini model. It is telling you that it used Gemini model. Why it used Gemini model, I'm not sure. Let's run this query again. This time it's used GPT-4 Omni. You see this? When we use Gemini's 2.5 Flash, we were getting hello, I'm doing well, this, and then here I'm getting hello, I'm just a program, and blah blah blah. Okay, so you get this point. The only interface that I have to remember is this, and the MLflow is going to take care of the traffic routing for you. Okay. All right, so I think that would be it for this video. But what I would like you to do is you can do pretty interesting thing in your production application. If you are using MLflow heavily, you can add fallbacks. Obviously, if let's say both of these models fail, then which model? So in production, you don't want a user to hang in between your requests. So you would want a fallback mechanism with which those models can be called. Now, two important features which are not yet there are called usage tracking and rate limiting. These two features will be coming soon, and I will be covering these also when they as soon as they arrive. So in this video, I just wanted to showcase how you can use MLflow's AI gateway feature, and how you can create APIs, and how you can create endpoints, and split your traffic between those. Okay, so thank you so much for watching this video. Let me know in the comments what you think, and if you have any feedback, please do give me that feedback. Thank you so much. Have a nice day. So I have a very simple chatbot like app here. If I send messages to it, it will respond. I can ask various type of questions like how is the weather, and it will respond. Now in this video, we will take this simple fast chatbot that calls an LLM, and we will add real observability step by step. And I'm not talking about just logs. I mean tracing, latency, metrics, token usage, error tracking, saving request and response artifacts, so we can debug issues like slow responses and random failures. So I hope you are excited for this video. I have set up most of the code already so that I don't spend time on setting up the chatbot. Chatbot is ready. We will just be first of all reviewing the chatbot functionality, chatbot code, so that you understand what we are going into. So it's a simple Flask based application. Here we have two routes. One is home and another one is for handling the response. Now this route takes care of the OpenAI calling, and this home route takes care of the rendering of index.html. Here in the index.html, I've got simple div setup. You can see we have got this app and we have got history. This history div would hold the historical conversation, and this sand will hold the input and the button. Okay, and when we click the button, this handle click is going to handle the calling of this API. Now the way it works is we create some bunch of variables for message and history, and we store the context using this message previous messages. And after each click, we basically create these JSON like structure, and we push this into previous message. And when we are so after that we append the history, and then after appending the history, we are just fetching the response which exists here. And while fetching the response, we are passing the user's message and the context. In fact, user's message is not even required. We will be using the context to basically call the API. So you can see here, we are getting that context value from the data that we receive from the API request, and we try to call the API. So this is how the current chatbot looks like. It's a very simplistic chatbot. The idea was to show you how you can add observability within an existing application. Now let's talk about the baseline problem that we have. Okay, the baseline problem is we don't have any visibility. Visibility into what? Suppose I send a message. Okay, I send a message, and suddenly those responses are very slow. Okay, so right now our app is working, but if it becomes maybe slow or fails in production, we have no idea. Now why it is happening? Maybe the LLM is slow. Was our app code slow, or was it because of some exception? We don't have any idea. This is exactly where observability exists. So we can answer what happened very quickly. Okay. All right. So how are we going to proceed with it? Let's first of all open the application code. So what is the first thing that we want to do? We want to add a request ID for correlation, so that each request can be tracked. Okay, so every user message gets a unique user ID. Not user ID, but request ID. So you can find that exact trace or run later. Now, how are we going to do that? The first rule of observability is correlation. That is correlation with, so your responses have to be correlated somewhere. Okay, so if a user says my request failed, you need one ID that connects browser to the backend, and by backend will be connected to the LLM call, and LLM call will be connected to logs and traces. So we will add a request ID and return it to the front end. That is the idea. So let's do that. So first of all, we will be importing a package called UUID. Now this UUID basically gets us some unique identification. So we'll be doing that. So inside the response, what we can do is we can do something like request ID is equal to what we need to do is we need to get a request dot headers dot get, and inside here I will say x request ID, and if it is not present, I can say something like stir UUID dot UUID4. Okay, so I just get a ID and I try to extract it from this request. Okay, now I need to return it. Where? I can return it here, right? So right now I'm sending the assistant sending the message with only one key. So I will also add a request ID, and here I can have a request ID parameter that I am generating here. So the idea is that it will try to extract it first from headers. If it is not able to find it, it will just create one. So if it returns, if this get operation returns none, it will just set it, and then we are sending it back. Now what do we need to change in the front end? So if I go inside this index.html, in the index.html, now I need to basically pass a request ID. So how can I do that? So to be able to do that, what I can do is I can generate a random ID here also. So I can use something like a crypto library. Okay, so now what we need to do is after adding this into Flask app.py, next step would be to send this request ID from our front end. So for that we can use crypto package in the JavaScript. So I can do something like crypto dot random UUID, and then I can save this in a request ID variable. Okay, so after we save this, what we need to do is we need to I need to define it per session, per request. So I will just clear this and I will create this variable here. After we have the request ID, what we need to do is we need to create a header key called x request ID, and I can pass this request ID here. Okay. After this step, what we can do is within this, then when I process the data, what I can do is I can process the text. So basically right now I'm just passing this as assistant message, but I'm not passing any request ID here. So I can also have a request ID embedded in between. Okay, so in the assistant element dot inner HTML, what I can do is within here I can create a simple I can embed a simple HTML tag called small. Okay, and within here I can have the request ID, and I can pass dollar here, and I can pass request ID here. Okay, after this step is over, now what we will have is we will have this request ID for every response. So every response comes with request ID, and we would want this request ID to be used somewhere. But first let us see how it looks like in the dashboard, in the app. So hey, let's send the message. So the response comes with a request ID. Now let's pass some different message. Maybe what is the capital of France? Okay, and you see this request ID is different than this request ID. So each response comes with a unique request ID. Now we want to go to this server code again. Now what we have to do is we need to install MLflow and all I have already installed. So you can check out my other videos where I showed the setup of MLflow and other packages. So what I can do is I can go ahead and start the MLflow server. So what I can do is I can do something like MLflow server. Okay, so it's saying the port is already in use. So what I can do is I can specify port here, maybe 5001. Now it should run, and let's navigate to the UI 127.1. So now you can see we have got the MLflow UI. We have got experiments, we have got models, we have got prompts and AI gateways. Currently no experiments exist. We'll be doing that in a moment. So now what we want to do is we want to create our first monitoring signal, and that is latency. So the idea is that we want to log the latency total, essentially total request time and latency for the LLM. Okay, so what we want to do is we want to basically track the latency of the model. Sorry, not the model, but the request. So how can we set that up? So what we have to do is within our server, we have to import the MLflow, and after importing it, we can, so now after importing this MLflow, we need to set the experiment. Okay, we can either get these details like experiment name and MLflow tracking URI from either environment variables, or we can set them manually. So what I can do is I can do something like set experiment here, and here in the experiment, what I can do is I can name it whatever I want. I will name it maybe something like Flask chatbot observability. Okay, so this is the experiment that we have. And how do we measure the total request time? So I have already imported the time module. Here what I can do is I can do something like start time, and I can do something like time dot time, and after the request ends, what I can do is I can do something like end is equal to time dot time, and after this we can log these metrics. So we can do something like MLflow dot start run, and within here I can do something like, one second, MLflow, sorry, in the start run I need to pass with start run I need to start with this as start run. Now MLflow dot log metric, sorry, and within log metric I will name it as latency total S, or maybe total, and I will pass here and minus start, or maybe we can do something like total latency. We can define a variable called total latency and minus start. Total latency. Okay, so I will log this total latency here, and we can log, so usually in production systems you can log total request time, because in production scenarios you won't be just making one LLM call, you will be having some database calls, some Cosmos DB or maybe Dynamo DB calls, so you would want to log all of that. But let me show you this in action, okay, quickly. So I will just refresh this. Okay, now let me also refresh this quickly, but before okay, so before this let's send some requests. So what I will do is let me see if my server is up and running. Yes, so I will say, hey, let's wake the LLM up. What is the weather? Let me see. Okay, I think I got some error. What is the error about? It's saying node name, the above node name is not found. What is this error about? Let's see. I think it is not able to find something, although our server is running. Yes. And do we have ML runs? Yes, we have the ML runs. Why exactly it is failing? What it is not able to find? It's saying node name or surname not known. In my previous videos, we explored MLflow and understood how powerful it is for experiment tracking, model management, and building production-ready ML systems. But in real-world companies, MLflow is rarely used in isolation or in localhost. It is usually deeply integrated with platforms like Databricks or maybe Azure. And this is where things become incredibly powerful, because Databricks gives you MLflow built in, no installation, no setup, and even no configuration. So in this video, I'll create a brand new Databricks account using the free tier, show you what compute resources you get, what you can do with the free account, and most importantly, how MLflow is tightly integrated into Databricks. We will create a notebook, run an MLflow experiment, log parameters, metrics, and models, and then see exactly where everything appears inside Databricks. I'll also show you how collaboration works on Databricks, how to add users, create compute clusters, and assign compute to different users. By the end of this video, you will understand how MLflow actually works in real enterprise environments. So I hope you are excited. Let's get started. Okay, so the first thing that we want to do is we want to create and set up our account on Databricks. So I will navigate to databricks.com and I will navigate to the login page. Under the login page, we will have to create a new account. And for that, you can use your Gmail account or any other emails that you might be having access to. Okay. So let this page load. It is taking surprisingly low amount of time, but let's wait. Okay. So I don't want to use my existing account. I'll just log out. And now you can see I'm getting several options. I can continue with my email, or I can continue with Google, or I can continue with Microsoft. I'll choose this option, continue with Google. And I will try to use a brand new account which I haven't used before. So I'll select this one. Now it will ask me a bunch of clarification and confirmations. So I'll just continue because I trust Databricks. Now, after this step is over, it will try to ask us to set up some, I guess, clusters, because essentially Databricks runs on cloud, right? So you can attach your existing cloud, or you can basically work with. Okay, so you can see what will you use Databricks for. So you can use it for personal use, or you can use for basically work. Okay, now you can get a free edition, or you can just start a trial with Express setup. So I'll select the start trial with Express setup, and let me also try changing my Wi-Fi. 1 second. Okay, so I'll just change my Wi-Fi really quickly. Give me a sec. Yeah. So yeah, so now it is basically going to ask me the location, because in the backend, Databricks is going to set up certain things like servers, compute options, and all. So I'll just select my nearest location. Maybe let's select India for now. I'll continue with it. It's saying solve this puzzle. Obviously, it will make sure that I'm human. Okay, but I am human. So I'll just click submit. Verification complete. Now let's wait for it to complete. Now in this 14 days trial, it is going to give you some, accesses, like you can have serverless compute. It will be a premium kind of access, and you can essentially create notebooks, create compute instances, all those things you can create. So this is the interface that you get. Now, what I want to show you in this video is I want to show you this lower left section, because that's where MLflow features are integrated. Although MLflow is tightly integrated with all of Databricks, but if you come here, you will see these experiments, you will see these features, models, and serving, and even the UI also. You can see the UI is also basically completely taken from the MLflow's open source models, which I had been showing you for the past couple of videos. So as you can see, you can go to experiments and you can see all those experiments that you have created. Now the question arises, how do you log things here? Because in the local setup of MLflow, what you used to do is you used to create runs or create experiments in your maybe scripts or notebooks. So you can continue with that here as well. I want to first of all go to this compute option, because to be able to run your script locally, you had local Python installed, but here you will be relying on the compute provided by Databricks. So I'll come here to the compute, and on the compute you can see serverless starter warehouse. Now this warehouse has been provided for free for at least 14 days. You can try it out. So this warehouse is something that you can attach. Now what does it mean to attach it? So whenever you are running some script or some notebooks, you can attach this serverless warehouse. So I'll just come to my workspace. Now workspace is basically a container of all your files and notebooks and everything. Okay, so I'll come here and I'll just go to create and I'll select this notebook option. Now once I select this, so you get this really nice and sleek notebook interface, which I really love, because you see it's quite user friendly and it looks minimal and professional. Okay, so to be able to log things in MLflow, obviously you would need MLflow support. Okay, so I would like to import MLflow. Now to be able to run this, I have to attach the serverless compute. So I'll just click on serverless GPU, and now I can basically run this script. So let me run this. Let me allow this. One second. Let me somehow this is not loading. Yeah, so now it's connected. So now let's import the MLflow. Okay, so our MLflow is loaded. Now the workflow, the common workflow is that you have a training script using maybe any package such as Scikit-Learn or maybe PyTorch, and you log things, right? But for now, we will just simulate whatever we could. And also you see this auto completion that Databricks is offering. So AI is integrated, coding assistant is integrated within Databricks, so you can just use it. But for now, I'll just not use it. So I'll just manually type start run as run. And now I will just, one second, I just ran it, which is going to throw an error. So what I'll do is I'll just log a metric. Okay. And I could have optionally also created a experiment. Let's create an experiment in the top cell. So I'll MLflow dot create experiment. I'll name this experiment as Databricks YouTube demo. I'll just run this, and here it's saying an experiment name must contains an absolute path. Oh, I see. I forgot it. So I'll just accept it and run. And here in place of this, one second, I'll just, let's run this and let's see. Parent directory does not exist. I think we need to grab the directory here. Somehow it's not working. So I'll just do one thing. I'll import OS and OS dot get current working directory. Okay, so workspace. So I'll just grab this email, this path, and I'll paste it here. Okay, so now if I run this, okay, so I should be able to get the experiment. Okay, so now after the experiment has been created, we will be using that experiment, and now let's log something. So I'll just try to log some parameter called theta. I'll log it as 360. And if I run this, now the moment I run this start run, it automatically detects it, and it basically is telling me that you can go into the experiment in MLflow to basically see this run. So I can go into the experiment, I can open this in new tab, and under the experiment, I would be having my experiment Databricks YouTube demo. And as in the local setup, you might have seen, if you have seen, if you have watched my earlier videos, it asks us to basically check the experiment type. So I'll just go ahead with machine learning. And now in the runs, one second, why no run is logged? Okay, one second. If I come here, oh, I see. I got it. So what happened was, when I started this run, I did not basically provided the experiment ID here. So, and that is why that run was logged into a default run. Okay, so if I run this now, and now if I refresh this, we can see in the Databricks YouTube demo, we are able to see this run name. Okay, so this is not a MLflow tutorial. This is a tutorial about how you can use Databricks to do experiment tracking, to do whatever we have been discussing for the last, bunch of lectures. Now, I want to talk about briefly some of the, I feel, which are cool features of Databricks managed. First of all, you can do collaboration in a very seamless manner, and everything about user management and all is managed by Databricks. Now, this can be done even with the local MLflow setup, but the problem with that is there is lot of overhead and operational expense. So what you can do is, you can come here and you can navigate to settings, and under the settings you will see this identity and access. So currently from the email that you have logged in and set up this account, you are kind of a pseudo user, so you are a admin. Now you can manage users, you can manage service principals. If you have worked with cloud, you would understand that service principals allow applications to talk to softwares in a and it allows to authenticate those applications in a automated manner. So I'll just come here and go to users. Now what I can do is, I can add users by their email. I can invite them to basically work on this workspace. And not only that, I can have multiple workspace. I can create more workspaces. Okay, so now if I go to users and if I go to add new, I can type out the email. Let me type out one email. Maybe I'll just type out my personal rahul.gmail.com. So if I add it, okay, I think since with this account I already have got one Databricks account setup, so that's why it's not a new user. So you get the idea. The moment I sent out the mail, I will get this kind of invite. One second, let me show you. So this is the kind of invite I will be getting. Join your team on Databricks. This person is inviting you, and if you click on join, you will be able to join them on their basically on their workspace. Okay, so with that said, these are the things that you want to do. Obviously, the account that I have set up is basically comes with a 14 days trial. After 14 days, you won't be able to access anything. But yeah, so one important piece which I wanted to discuss was this user management, and then there is this compute option. Now, there are in the compute option, you have got options to create computes. So you can have, let's say, if I click on this manage, what you can do is you can manage access policy for the compute. Okay, you can navigate to this compute and you can create a compute. So I can go ahead and create a SQL warehouse, and in the SQL warehouse I can select the size, and size directly is linked to the performance of the server, or in the Databricks and Snowflake terminology, these are known as warehouses, but they are essentially compute instances. Okay, although warehouses, when you hear the term warehouse, you might think it's a storage thing, but no, it's not a storage, but rather it's compute cluster, you can say. And you can say here scaling, you can set what will be the minimum number of instances, what will be maximum number of instances. You can set the cluster size and things like that. Okay, so you can create it. Not only create, let me create it really quickly. Small instance, and after creating it, you can attach it to some user. So I can manage permissions. So I can maybe do add people. Since currently I don't have any users added in my workspace, I'm not seeing any results here. But you get what I'm trying to say, that the moment you add one user, you can basically add them and give them access to this compute, and they can then use it. Now the next thing, after talking about users and compute, next thing that I want to talk about is how do you install packages. So if I come here in the workspace, if I come to my untitled notebook, so currently you were able to import MLflow because MLflow is tightly integrated already with Databricks. But what about maybe other packages that you might not have access to? So for those packages, what you could do is you can insert the code, and you can do something like pip install. So but first let me show you what happens if I try to import OpenAI, or maybe from OpenAI import OpenAI client. Okay, so if I run this, it's saying module not found error. Although if you notice something interesting is happening. The moment I try to import OpenAI, it is suggesting me to basically do this OpenAI.autolog so that all the OpenAI traces will be automatically logged. Anyways, so let's install this package. So if I run this, it will be installed on my serverless compute. And after that, I should be able to use it. So let's now run this. And now I'm not getting any errors. So I should be able to now load the, not load, but connect to the OpenAI client, and I should be able to use it. Okay, so there are tons of features. It is very difficult to cover all of them in 16 or maybe 20 minutes video, but I wanted just to give you a taste of what is possible with managed Databricks. It's awesome. If your organization or you don't want to manage all the setting up of MLflow locally, or maybe deploying that open source MLflow, it's wonderful. So yeah, so I think that would be it. Thank you so much for watching this video. There would be a lot of interesting stuff which are coming related to MLflow and Databricks on my channel. So stay tuned, subscribe for more content, and let me know if you want to see any specific topic gets covered. Thank you so much. Hi everyone. Let's start talking about experimentation and runs in MLflow using Databricks. Now, before I talk about experiments and runs, I would like to talk about few convention changes that we follow. Not follow, but rather we have to follow these conventions because we are now on Databricks. What happens usually, what is your workflow when you are working as a solo developer on MLflow is you install MLflow on your local machine using maybe terminal, and then what you do is then you try to start the MLflow server, and you try to create some backend store and artifact store. Now there are a couple of options. You can either set these stores as a local location, or you can set them to remote location. So you can have a SQL database that you can set for backend store. And for those of you who don't know what backend store and artifact store are, to summarize, a backend store stores all the experiment and run metadata, whereas artifact store large files such as large models and Python files and things like that. Okay, so what usually we do when we are doing MLflow locally is we try to set up the artifact store to either local location or some remote object storage such as S3 or maybe Azure Blob Storage. Okay, so with that said, let's get started with the MLflow on the Databricks. So I have to come here, and on here I see this new option. I can click on it and I can create all the different bunch of things that I wish to do on Databricks. Now Databricks is a very you can say complex and comprehensive piece of software. So rather than covering all of that in one video, let's go ahead and create a notebook that we want to use for our MLflow demonstration. So I'll just create this notebook, and I can come here and I can rename this notebook, and the UI is quite minimal and seamless, and it works quite wonderful. So what I'll do is I'll create this notebook as experiment and runs. Okay, so before you run anything, you need to attach the server on not a server, but rather a compute instance that you will be using to run this notebook. So I will create I will select this serverless option, and I will select the serverless GPU. This seems like some sort of bug wherein if you just keep clicking on it, it won't start, but it will throw this error. But now you can see it has started because we see this green icon here. Okay, so what we do is we import MLflow, and after the workflow is that after importing MLflow, you start one experiment. So you can have an existing experiment, or you can create an experiment from scratch. So let's navigate to the left, and let's navigate to the experiment. So I'll open this experiments tab in a new tab, and here I see no experiments got created right now. So what I can do is I can set create one experiment. Now here something is different than what we do in the local setup. So in the local setup, what we can do is we can simply create something like demo experiment. We can name anything that we wish to do, but it won't create the experiment. Rather, you need to provide the full path of this full path of where this experiment would lie. Now how do you get that path? So what I can do is I can import the OS package, and I can print my OS current working directory, and this would give me the path that I have to basically append before it. So I can just get rid of this, and I can grab this string that I've got. So I'll just copy it from here, and then after this whole email, what I'll do is I'll add the demo experiment here, and if I run this, it should create the experiment. It will first try to locate experiment with this name. If it is not able to find it, it will just create it. Let's wait for a couple of seconds for it to run. So you see this. Please read through these logs, because these are very important logs, and when things go wrong, you need to debug those. So if you come here, you can see that experiment with name this does not exist, creating a new experiment. And after that, it has created one experiment, and it has basically set this thing called artifact location. Now what exactly is being used for artifact? Artifact is essentially a a store for large files and models. So what Databricks has done is it has created this location for artifact storage. Okay, so now what we can do is we can use those experiments. Now that this experiment has been set, what we can do is we can simply come here and we can log all type of things here. So what I can do is I can do something like with MLflow, and you can see AI is starting its work. So it is basically giving me some sort of suggestion. Now after starting this work, I don't need to provide the experiment, although you can provide it by providing the experiment ID. Now where do I get this ID from? You can see from the previous run also you get this ID, or if you don't like if you are not available, if you don't have this output ready, what you can do is you can come here into the experiments tab in Databricks, and after that you can click on it and you can grab the experiment ID from here. So there are a couple of ways. And also, yeah, so this is important piece of choice that you need to make. So in MLflow, experiment can be of either two types. It can be GenAI based experiments or traditional machine learning based experiments. For now, I'll just click on this. Now, within the experiments, you can have multiple runs. Now, where would you get the experiment ID? So if you come here to the URL after the experiments, you see this number. This is your ID. So from here also you can get your ID. Okay. All right. So let's now move on. So you can specify the ID here, and you can also specify the run name. So I'll specify the run name as first run. Okay, or rather first test run. And after this, would start the MLflow's run context, and within here we can log all sorts of things. What kind of things we can log? I have covered these things in detail in my previous MLflow videos, where we did MLflow locally. Now what we can do is we can test this out really quickly. We can log params, and in the param we need to provide the key value pair, and if you have a dictionary ready, you can provide that dictionary and it will create all the key value as the parameter. It will log all the key value as the parameter. So now in the MLflow.log params, what I can do is I can do something like, maybe you would want to log theta, so I can have that as either string or integer. I can also do log params. In the params, I can provide the dictionary. I can say something like alpha, and alpha could be something like maybe 0.33, and I can have something like beta, and I can have maybe 12. Okay. Now after logging params, I can log metric, and as you can see, the built-in AI auto completion of Databricks is giving me all sorts of suggestions. So I can obviously, if I wish, I can basically hit tab, and I can basically use that. Okay, so I'll just log the accuracy, and then finally I would like to show you how you can log the artifact. Now, since artifact is something that is usually considered large compared to params and metrics, so artifacts are models and files. So now, before logging the artifact, you also should be having artifact, right? So let's create the artifact here. So if I click on it, I can come here and create, and I can create a text file. This will open the text editor, and I can create all sorts of text editors here. So let me create a Python file here. So what I'll do is I'll name this file as sample.py, and here I'll just add bunch of things. Import os dot, or rather print os dot get cwd. Okay, now I can use this file to basically log the artifact. Currently the file is not being displayed here, so I'll just refresh it, and if you can see, my sample.py is here. Now what I can do is I can come here and I can log my artifact, and in the artifact I can provide the path of the file where it exists. I can either provide the full path, or I can, if I am running this notebook from the same directory, I can just provide the name of the file. Now if I hit enter, it should create this run in the experiment called this demo experiment. Now notice here, this nice thing about that Databricks is that after running, it is basically giving you the direct link to access the experiment. So I can click on this right here, and I can close the previously opened one, and once the experiment is opened, I'll see the run, first test run. If I open it here, I should see all the params and logs that I created. So we see accuracy, we see the parameters, and if I come to the artifact, I will see the sample.py file being logged as an artifact here. So I can open it and I can inspect it. Okay, so I think that would be it for this video. In the next video, we will be looking at how we can do manual logging and auto logging using MLflow and using sklearn. Thank you so much. Hello everyone. In this video, we will be looking at auto logging and manual logging. And in fact, manual logging is something that we already kind of looked at, because in the earlier discussions, we saw how we can log things using MLflow.log, and then whatever we want to log, that name. So log artifact, log params, and log metric. That we have already seen. So that is a manual logging. Okay. Now imagine that you are basically training a model using Scikit-Learn, and you have to log using this method. It will work if you want to have more control over your logging functionality, but then MLflow comes with a flavor specific auto logging functionality. And when I say flavor specific auto logging, what I mean by that is different frameworks have different kind of things that have to be logged. For example, the things that are going to be logged for Scikit-Learn models will be different compared to, let's say, PyTorch based models. So that is why MLflow comes in various flavors of auto logging. Now let me show you how we can basically take advantage of the auto logging. So before doing anything, you might want to set up this experimentation and all. If you don't know, you might have to watch the earlier discussion that we had. So here, if you see, we are logging things manually. Now I need to get some sort of training script. Okay, so what I can do is I can come here, Scikit-Learn basic training example. Okay, and it should give me some examples for the training. So I will just grab some examples from here. Let's see. Let's use the classifier comparison, not here. I guess these are I think this example I can grab. So what I'm doing is I'm loading the iris, so I can just grab this. So now if I just come here to the experimentation and run, and if I run this, you see all of the packages are pre-installed, so it will be already involved. Now you might be thinking that how are they already included? So you can come here and you can click on this button, and you can click on the configuration, and inside the configuration you see this dependency. So you will get this pip requirements file, and inside this sorry, not here but rather here. So what all you need to what all things are already installed for you, you can come here and you can look at that. And if you want to add more things, you can basically add more packages. You can say you can even add your requirement.txt file. Okay, let's come to the topic. So what I can do is I can one by one run this script. So let's run this and let's load the data. Let's run this, yeah. And after that we can run the third step, that is train test split. And we can fit the model. And notice here, currently I'm not concerned about logging here. Okay, so now if you see, I have achieved the model accuracy of 1.1. Now let me navigate to the experiments. So here is my experiment. Let me go to the experiment. Let me see if I don't have any new run. Why? I was explaining the auto logging, right? But why it is not auto logging? What is happening here? So let's do one thing. Let's run all these cells again. But this time what I'll do is I'll do MLflow dot sklearn dot auto log. One second, auto log. Okay, so let's run this. Okay, so now auto logging has been enabled. Now let's run this again. Now it should log, right? Let's see. Okay, so we should be seeing model accuracy as 1. And let's, after this step, Okay, so we have got k nearest neighbor classifier and we have got model accuracy. Let's refresh this page and let's see if we have got any more run or not. Okay, so we are seeing one run, right? So if I open this, it has created a run called efficient crane, and inside it you see a lot of information, like you have got training accuracy, you have got testing accuracy, you have got these params like metrics param, n jobs and things like that. Okay, so if I go to model metrics, you will get all these model matrices. You will get artifacts also logged. When I say artifact, you will get the model. So entire model is packaged into a format called MLflow model. You will get model.pickle. So model can be reproduced using different you can say flavors. You have got requirement.txt files to reproduce these things. You will get model.pickle file, you will get conda.yaml file. So all these things you are getting when you do this auto logging. But currently you don't have any control over run, so run gets created automatically. Now what do you think you need to do to enable this run functionality? So what you can do is you can take this entire thing. So let me not entire thing, but sorry, let me do one thing. Let me now with mlflow.start run, and inside here I'll pass the run name as maybe manual auto logging run auto logging. And then here what I can do is I can do model fit again. Let's try that. And then after that, let's try only model fit, nothing else. So if I run this, let's see what happens. So here I'm not doing anything. All other things are done before this run context. But let's see if we have got any other run here. Okay, it's loading. So we are seeing this auto logging. So you see, still even if I do just the training part here within the auto logging, within this I'm able to get all these artifacts here. Okay, cool. So this is how you do auto logging using MLflow. Now if you had to do, let's say, manual logging, then you could have just done MLflow. Now please be aware that if you do auto logging again and run it again, then there will be one more auto logging run get created. So runs differ by their ID. So you might have to basically grab this run ID, and if you want to basically reproduce this in the same run, so I have to do run ID, and inside here I can pass this. So now it will use this run only. Okay, so I can now comment this out because the model is already there. I can do something like log metric. I can do something like extra metric, and here I can do some random values. So if I run this, it should log the extra metric here. Let's see, let's refresh it, and we should be able to see extra metric. And this is an example of manual logging. You see this extra metric. Okay, so yeah, so now in the next discussion I would like to discuss the concept of nested runs. Okay, so let's continue with that. Thank you so much. So let us talk about how to do a nested runs in MLflow on Databricks. Now the concept is quite similar as we do nesting locally on MLflow. So let me show you that. The idea is that right now the way we are making these runs is we create a run and we open this run and we see the outputs within that run, right? The idea is that we can have a use case where I might have you can say a parent run, and inside that parent run you have got different experiments. Maybe usually the way this experimentation works is you have a experiment as part of something large. You have some hypothesis that you are testing, and you have got various runs which basically test that hypothesis. Now you can have a situation where you have a hypothesis, and under that hypothesis you have multiple other hypotheses. I hope you are getting the point. You will get it in a moment. So I'll do this MLflow.start run. Okay, so I'll create this as maybe parent run. I'll name this as parent run, and I'll create this as parent. Now within this run, what I want to do is I want to start one more run. Okay, so with MLflow dot start run, and I would like to name this as maybe child run 1. Okay, or maybe child 1, and here I need to specify a parent ID. So I'll say parent run ID will come from this parent. Okay, so I will say parent dot info dot run ID. Okay, so as child 1, and here I can do something like MLflow dot log. You can do all sorts of things that we have already seen. So log params, and here I can log my param 1. Okay, similarly I can copy this couple of times, and I can do child 1, child 2, child 3. I don't need to necessarily change these names, because I am running this only after this gets executed. So and in this manner you can see you can create a hierarchical relationship where within the child run also you can have multiple runs. Okay, so let me run this and you will see the output, how it will look like. One second. Why the syntax is wrong? Let me see. Line number 3 syntax is wrong. Why? Okay, I think name is something that I did not correctly specify. Okay, so and after that, okay, so what we can do is we can simply run this, and let's see. Start run got an run name. Sorry, run name. Run name. Run with to start a new run first, and the current run with start a nested run. Oh, okay, I think so. Okay, so yeah, so after specifying the parent run ID, I need to also specify the nested argument, which is going to be true. Okay, so I need to basically get this nested equal to true in all the run definitions. Okay, now let's run this. It's saying, okay, shit, I needed to, so there are a lot of bugs here. Provide this as dictionary, not set. Okay, now it will run. So after this, we will see lot of, because okay, so let's refresh this. Okay, so the only correct parent run would be the latest one. So all these things were created because we were getting the errors. So let's delete this. Now you'll get this parent run, and if I expand this, you'll get child 1, child 2, child 3. Okay, and I can open the parent run also, and I can open their child runs separately. So you get the idea. Like if you have a sub hypothesis, and inside that sub hypothesis you want to try out bunch of parameters, bunch of metrics, and bunch of models, you can try out the nested run functionality of MLflow. So yeah, so thank you so much. Now we will be moving ahead and looking at how model registry and serving of model looks like with Databricks. Let's move on to that. Thank you. Let us now look at how model registration works on Databricks, and it is a little bit different than what we normally do in local MLflow setup. Now on your screen, what you are seeing here is I am not into the MLflow section, but rather this catalog section. Now this catalog section is where your model will eventually land. Okay, so you can log your models here in the experiments, but eventually if you have to register your model, you need to create those here. Okay, so what I have here is you have got this organization level segregation, and in the organization you have these workspace and system. What are these? These are known as catalog in the Databricks terminology. And if I expand this within the workspace, you see two different what we can call them as schemas. So we have got default schema and we have got information schema. And obviously information schema will have some you can say information related to Databricks, and then there are system specific you can say catalog. So I've got two catalogs here. Sorry, not catalog. I've got two catalog here, workspace and system. If I expand the system catalog, within the system you will see there are some you can say options, like for example MLflow. If I expand the MLflow, within the MLflow, I will have these you can say schemas. Okay, sorry, the schema is MLflow. These are tables. So if I open the experiments latest, this table will have all the details related to my experiments, like account ID, who ran the experiment, what was the workspace ID, what was the experiment ID. Now how can I query it? I can query it in the SQL editor. So I can open this SQL editor in a new line, in a new tab, sorry, and then I can explore this. Now why I'm telling you all this is because here there is a shift in mentality. In your local setup you have everything logged locally, but here these things are being saved in the catalog here. Okay, so now I can see the SQL query. I can create a new SQL query and I can basically run anything that I wish to run. Okay, and you can see I have got these users. Now I have got two users here. One is the user that I added, and I have got one more user that I can clearly see here. Okay, so now if I open the SQL query, I can select the workspace and I can select the schema within the workspace. Workspace is where? Workspace is here. In the workspace, I can select what? I can select the default schema. Okay, and within here, so this is what I wanted to show you, is that how catalog looks like. Now let me come to the model part. Now within the catalog, so if I expand the default you can say schema, within this I can create some things. What are all the things that I can create? Let me click on default and let me click on let me come here to the right. So if I click on it, you can see you can create several things. You can create a table, you can create a model, you can create metric view, and you can create volume. For now, let's go ahead and create a model. Let me create a model, and I will create a model with the name, let's say I'll name this model as maybe sample demo model. Now once I have this model name ready, what I have is so I have got this model available in workspace catalog, default schema, and this is the name. So the way I'm going to refer to this model is I'm going to refer to this model as workspace dot, what is the schema name? It will be default schema, and then I can basically grab this name. So this is the fully qualified name of my catalogs model. Now what is the use of this? So the use of this is let me show you this experiment. So this is the model, this is the notebook that I have. In this notebook I am basically setting up a run which basically is creating a simple classifier model, and then it is logging the model. Okay, now you can log the model. At the same time, you can also register the model. So these two are different things. Logging model would just log the model and associate that with this run. Let me show you what I mean by that. So I'll say run name is equal to demo registry, or maybe demo catalog. Okay, so let me now do one thing. Let me not register it. Let me just log it. So I'll just run it. This is going to be demo catalog. Let's wait for some time, and meanwhile let's explore this further. So I want to take you to this system catalog, and inside this system AI catalog. In the AI you have got these models. So as I explained you can create models, tables, and variety of things. So I can expand this model, and you see these models are available. What are these models? So these models are LLM models. They are already registered by Databricks. Now what you can do with it? You can serve these models. How can you serve it? I will show you in later videos or later sessions how to serve these videos. But these LLM models, since these are very huge, Databricks took the effort of basically logging these models and providing you in the catalog. Now what you can do is you can just take these models and basically create the serving endpoints. Okay, so let's see. Okay, so this is completed. Now I can open this in experiment, this run. So let me open this run, and let's see what have we got here. So I see this experiment. We don't have anything, but if I come here in the artifact, I will see this model, right? Okay, so now I'm able to see this model. But if I go into the models tab from the left, I'm so here if I see, I don't see my model, right? So I do see my sample demo model, but I don't see exactly like, so this model is not here in this registry. Now where is this model? This model is only associated with my experiments. Okay, now if I open the sample demo model, it will take me to the catalog where from where we created it. But currently this sample demo model has no artifact associated with it. Now how can I bring my artifacts to basically to this model? Now we don't have anything, like even we don't have the first version. So you see there are no registered model versions yet. We do have the model, but we don't have the registered model versions to it. Okay, so let me go to the experiments again, and under the experiments I will come here into the not demo experiment, sorry, not demo, but rather this one, because in this notebook I did not refer to any experiment. So now let's let it load first. Okay, so one second, why it is not loading? Okay, so yeah, so this is the experiment name. When you don't specify the experiment name, it will refer to the notebook name. Okay, so now after that it is loading the run. So we have demo catalog, and if I go to artifact, I have this run. Now if you see this register model, you can either register it from here, or you can from here you can provide the register model name, register model name argument. And how are you going to provide that name? You will provide it by specifying 3 pieces of informations. Okay, first one is going to be catalog name, second one is going to be schema name, third one will be the model name. So if you provide all these 3 names, it will take this model artifact associated with this run, and it will put it inside this model. Let's do it from here. So I'll click on this registered model, and then I need to select which model I will be using. So you have got several models here, so you can choose any model that you wish, but we created the sample demo model for this, and I'll register it. And the moment I register it, so it started registering run this. Now if I come here and if I refresh it, so I'll just see by refreshing whether my sample model has been basically a new version has been created or not. Okay, so currently we don't have any versions yet, But let's wait for some time and let's see how long it takes. But this is the process that I wanted to show you, like how cataloging works and how catalog is actually different than how we do modeling in like locally. Okay, so let's refresh it again and let's see if it does not happen this time. I'll just pause this video and resume it once we have this registration completed. Okay, so we have the registration complete. You can see now version 1. So if I click on version 1, I will be able to see the model artifact paths. Now once I go here, I can click on the serving also. Like let me show you 1 second. So yeah, so from artifact I can look at the exact models that basically got created here. Okay, so with that said, I think that would be it for this video. Now we are going to be looking at how to serve a registered model using Databricks managed serving endpoints. Thank you. Hello everyone. So in this video, we want to look at how we can actually take our registered models and create the endpoints. Now I went ahead already and created one endpoint already, because it takes some time to container to spin up and actually start serving our models. But let me meanwhile, while this is being created, what I want to do is I want to do couple of things. First, I will show you how when I click on this create service serving point, how does it look like, and then we will be reviewing this endpoint, and then we will be try to use this endpoint. Okay, so I think there are a lot of things that we need to do. Let's get started. So there are two different ways by which we can create these endpoints. First is we can go inside the navigate to the models, and we can choose the models that we want to create the endpoints for. So for example, if you want to deploy the Claude Sonnet 4, you can click on it, and then you can come to this top right button that is serve this model, and if you click on it, it will automatically take you to the serving page, and it will ask you for some parameters like what will be the name of the output, name of the endpoint, and then entity details. And also for your information, in Databricks, entity is known as anything that is there in the catalog. So catalog can have tables, and it can have models, and it can have other things also. So and that follows this pattern, that is catalog dot the schema dot the name of the entity. Okay, so this is how you create the endpoint. So you can obviously specify the name and you see this URL format. It will be HTTPS by default. So yes, your endpoints will be secure, and then there will be a user ID. So user ID will be depending upon what your user ID is, and then there will be .cloud.databricks.com, and then serving endpoints, and then whatever name you specify here will come here, and then invocation. Okay, so this endpoint, if you hit, you can call these models whatever you want to register. So let's try to basically let's go inside the models again, and let's open the sample demo model, and let's see when I so what I can do is I can serve this model. I can click on it and serve this model. I can then it will take me to the serving page as mentioned. I can have maybe a sample model, and then after that it is automatically basically filling the compute type, but depending upon the kind of usage you are dealing with, you can select GPU or CPU. You can select GPU small, GPU medium, and GPU large. And then there are these concurrency settings which you can basically select. You can select whether you want to scale out or not, and what will be the minimum concurrency, what will be the maximum concurrency. Okay, now you can also enable this scale to 0. I have enabled it in my previous serving that is currently in progress. We can enable the tracing also. it will basically track all the input output, and it is going to save this into your catalog. Then you can do the route optimization, and we can do that using AI gateway. So we have got under the AI gateway, we have got enable usage tracking. We can enable inference tables, and we can also select the table location. So I can select the catalog, I can select the schema, I can select the table prefix, and then we can obviously go ahead and create some tags, serverless usage policy, and then we can get some sort of alerts. So we can configure, let's say, email alerts, and on success or on failure, if you want to create the alerts, and then finally you can click on this create button, and it will basically start the serving process. Okay, now if I look at my previous endpoint which I created, now it's ready for usage. How can we use it? But before even using it, I want to review some of the settings. So you can see, as previously, the endpoint is this HTTPS secured version, then my user ID cloud.databricks.com, serving endpoints, my first endpoint, and then invocation. So after this, I can also look at my usage policy, like how it is basically performing. And so for example, if I can look at my latency. So Databricks is a complete end-to-end, you can say, monitoring and observability stack for you. MLflow is inbuilt, so all these things you are getting by subscribing to one tool. All right, so after this is done, what we can do is we can obviously delete it, but let's try to use this. So how are we going to use it? We can use it via curl. You can use it via Python. So let's try to use it via Python. So I'll just copy this command, and I'll come to my my notebook. Let me also save this notebook, maybe. Log and register model. Okay, so let's do one thing. Let's use it here. Let's try to use it here only. So we are importing OS request, and then create TF serving JSON, and then we have this URL authorization. I'm getting this Databricks token. Where is this Databricks token is going to come from? Let's see. 1 second. Okay, I think it will automatically for secure Unity catalog connection securely. Okay, data frame dot split. So where exactly is my token is going to come from? So let's see. So I did some digging. So this is from where we can get the authentication tokens, by coming to the settings. So I can go here and then open my settings, and inside the settings I can basically get the token by coming in the developer panel. I can click on manage, and I can generate a new token. Maybe I'll set the lifetime to 1 day, my token, and I'll generate it, and then I'll just grab this and I'll paste it here. So I won't be using environment variables for that, but you should probably use that. Okay, so now this is the token. The content type will be JSON. Then we have got dataset dot to dictionary dot orient dot split. So now I would want to basically first of all run this, and then I will take my x. So I will look at my x the way x looks like. So currently x is like this. So what I want to do is I want to score model, and I would want to provide my x here. So let's run this, and let's see what do we get. So what we are getting here is we are getting predictions, and the predictions are coming in a dictionary of list. So predictions.list. So it has scored all this into this JSON, and it has returned this. If I come here, I should be this graph should be updated. Let's refresh it, and let's see if we have got the latency numbers. So we did get the CPU usage, we did get the memory usage, we got provision concurrency also, but the latency is something that we haven't received yet. Maybe it will take some time, but anyways, see, the point that we wanted to make by creating this endpoint is how it would look to deploy one registered model via Databricks. Now this endpoint, if let's say this token is still valid by the time I upload this video, you can make calls to this URL. So this is really powerful. Now you are no longer creating these endpoints locally as we do using MLflow's open source. We are creating it using Databricks managed. Okay, so I think that would be it for this discussion. Now we will try to look at some of the GenAI stuff using Databricks. So thank you so much. In most machine learning tutorials, you learn how to train models. But in real industry projects, training is only 10% of the job. The real challenge is deploying models reliably, serving them, versioning them, and making them accessible to applications. In this video, I'll show you exactly how to take a real Hugging Face model, wrap it inside a custom MLflow PyFunk model, register it in Databricks, and deploy it as a production-ready endpoint. Specifically, we will install PyTorch and transformers, download a real embedding model from Hugging Face, wrap it up inside a custom MLflow PyFunk model, implement load context and predict methods, register the model in MLflow model registry, and finally deploy it as a live serving endpoint in Databricks. By the end of this video, you will understand one of the most important real-world skills in modern ML engineering. That is, how to deploy transformer models using MLflow. Let us start with making a plan of what all things we need to do in order to serve the endpoint and create and deploy our model that we want to basically deploy on Databricks. So we'll be following these steps so that we have a clear guideline and guidelines as we are progressing. First one is going to be install PyTorch and transformer library. Now we are not going to do anything on our local platform. The only thing that we are doing locally is just create this project1.txt file, nothing else. So I'll just go ahead and open Databricks, and I will just quickly log into Databricks platform using my Gmail account. And then after logging in, I'll create a new notebook and attach the serverless compute to it. I'll just go ahead and create a notebook, and I'll name this notebook as Transformer Model Deployment. Transformer Model Deployment. Now, what do I mean by the statement that I want to install some packages? Locally, we have Python, but here on serverless, how do I install my packages? So first of all, let me connect it really quickly. And then from here, I can go to more, and from here I can go to configuration. And inside the configuration, if you see, I have this added and installed. Now, the way you install the new packages, you write the package name here, transformers, for example. Now, the reason it is giving me this is because, one second. So the reason it is giving me this is because it wants me to use equal to for specifying the exact version, but I don't need to do that. And then I also need to do PyTorch. Okay, sorry, Torch. So I want to install Torch library and then transformers. But let me see if I have already got these installed or not. Transformers, I don't have this package, or maybe let's say Torch, I don't have this either. So what I will do is I will install these two packages really quickly. So I'll go to edit, transformers, Torch, and I will apply. Now when I apply it, it would take some time to basically install these packages. So let's wait, because it rebuilds the container and everything. So I'll just pause this video right here and I'll let it installed first, and then we can resume it. Okay, so as you can see, it took 3 minutes to add these packages. Now let us quickly test whether we have these packages ready or not. So from transformers, I will quickly try to import a submodule called a function, a class called auto tokenizer. So if this succeeds, that means my package is working fine. I can also see quickly if my import torch is working or not. Since it is loading it most probably means our packages have been installed. Okay. It says auto tokenizer is not found from transformers. Why is that? One second. Let's see. From transformers auto tokenizer, why it's not working? Did I spell it incorrectly or what? Auto tokenizer, why it's not okay, this time it worked somehow. I don't know why. Okay, so now I have imported the torch. Okay, so now our package imports have been completed. Let's go back. So we have been able to install this. We have been able to complete the first step. Now let us download the model from Hugging Face. Which model I am trying to download? So it's an embedding model provided as part of sentence transformers, and sentence transformer itself is built on top of transformers. So the exact model is Paraphrase Mini LM. The reason I took this model is because it's lightweight and yet powerful. So it's a powerful embedding model which we can use. So let me navigate quickly to Hugging Face platform. Hugging Face. Now from Hugging Face, I can search all sorts of models. I have already logged in, although you don't need to log in and you don't need to get a Hugging Face token for this video. And the reason for that is because this model is openly available and it does not require the use of this token. So I'll just search for this model that I just showed, and that is Paraphrase Mini LM. So Paraphrase Mini LM. So this is the model that we want to basically use here. And since this is L3 version, so let's go for L3 only. So Paraphrase Mini, this one. So this is the model that we want to get. If I go inside the files and versions, I can see the model files. So you can see model.savetensor is the largest file and it's hardly 70 megabytes, which is good. Now I need to grab these models and I need to make them available somewhere here in my Databricks notebook. Now how can I do that? So what we can do is we can download them definitely. But where will those downloads go? That's the one concern that we might have. So what we can do is we can create a folder. Maybe let's create a folder which would hold our model. So model files. I'll create this folder for model files. So now let me refresh it. Okay, so I've got this model files. Now what I can do is I can download my my models in this file. Now how am I going to download it? So the way to download it is by using it. So basically what I'll do is I'll quickly from transformers, I will import auto model, and if I run this, it will import the auto model, and auto tokenizer has been already imported. Now after this, what I want to do is I want to create two variables. First one is auto tokenizer, and it's already giving me suggestion of the command that I have to use. So it's called from pre-trained, and what will be the key? The key will be this exact key that we get from Hugging Face. So now I can provide this key here. So this will create my tokenizer, and similarly I can create a model. So auto model dot from pre-trained. Similarly, I'll paste it, and if I run this, it will give us some warnings like you are not using HF token and things like that, and it will download it. But where exactly it is going to download? For that, we need to basically create a variable called a model download directory, and it will point to this directory here. So I'll just try to copy this path. How can I copy this path? Yeah, so from here I can copy the path and I can paste it. You see workspace and model file. So this model files directory has been saved here. Now what I can do is I can do something like token dot save pre-trained, and I can do model download directory here. Similarly, I can do model dot save pre-trained and model download directory. So this would just take our model files and it will download, place these in here. Okay. And why are we downloading it? Because later we will be referencing it in our custom Python model that we will be creating. So if I run this, it should kick off the model download process. So we are seeing that it is basically downloading it. So yeah, so you see all these progress bars are showing that the download is in progress. So let's wait for it for a couple of seconds for it to complete. Meanwhile, let me see how I can, one second. Let me see. Let me close this first of all. Is it complete? Yeah, so it's complete. So if I refresh this now, so in download files, you see configs, model safe tensors, all these files are available now. Now I don't need to use these token and model variables. I can just use these one. Okay. So let's see how to use these now. So our next step is to basically learn to use these models that we just created. So what we will do is we will quickly take these TOK and model variables and we will try to see if we are able to use it on some text. So let's create some texts here. This is a sample text. Okay. So I'll just run this, and then I will, so creating embeddings on top of the text using the models that we just downloaded is a two-step process. First, we call the tokenizer on the text, and we get inputs, and then we pass these inputs to produce the, you can say, to pass through these inputs to the neural network. So in the text, I want to return tensors. So basically I want to tell it in which format I have to return the tensors. I'll say PyTorch, and then I would like to set the padding as true. Now why do I need to set padding as true? The reason for that is when you will be using text of different lengths, you will need to align them, right? Because one text can be smaller, another can be larger. You need to add some extra fields, extra tokens to be able to basically give you the same length. So if I run the inputs now, so you see we got input IDs and it was a much quicker process. Now we take these inputs and we pass it to the torch. So with torch dot no gradient. So we run it in a context manager, and we get outputs. In the outputs, what we get is we take our model. Where is our model defined? Our model has been defined here. Now, if I take my model, I just need to pass my input, sorry. But here, inputs is a dictionary, but rather I want to unpack it. So I'll just put a double star it. So don't get scared from this double star. It's just unpacking it. So input IDs and token type IDs and attention mask, all these are unpacked. So if I run this, it will take some time, like little bit of time. So I get outputs. Now, if I check my outputs, what will I get? I'll get a detailed output of all the hidden layers information, but I want to get only the last hidden state. So I can get last hidden state. I get a very long tensor. Now, if I check the shape of this hidden tensor, you will see it has a shape of 1, 7, 384. What is that? So 1 corresponds to the batch. If let's say I add one more text here, and if I run through this again, and if I check the shape one more time, you will see now it will have 2, which means this dimension represents which text we are dealing with. And this 384, you can imagine 7 different arrays of length 384. Usually we mean it across this axis, so that what we get is we get a 2 by 384 matrix, where each of this dimension represents the text and 384 is the actual embedding. So I hope you understand, and this is how we use this model. Okay, so so now what we need to do is we need to move to the next steps, and next step would be to create a custom PyFunc model and log that model in MLflow. Okay, so the next thing is to implement a custom PyFunc model, and exactly in that we will be implementing a class which will have 2 methods. One is going to be load context and another is going to be predict method. So let's navigate back to the transformer notebook that I had. I would like to import MLflow really quickly. Now I will create a class. So I'll create this class as maybe sbert and sbert custom model. And this sbert custom model is going to inherit from MLflow dot pyfunction dot pyfunc model. So we need to Python model. Okay, so we need to inherit from this, and we need to define 2 methods here. So I'll quickly define load context. This takes again itself, self means itself, and then context, and I'll just pass it for now. And then we will define a predict method. This predict method should take again self. It takes context as well, and it takes, I'll tell you how this context and all will be defined. It also takes model input. Okay, and it is expected, right? Now what do we do in load context? In the load context, what we do is we take the context that is passed. Now, how can we pass it? I'll show you when we have to log the model. So while logging the model, we define the context, and while passing the context, we take the context and we load the model, whatever we have to do, right? Okay, so now what I can do is I can assume that this context has a you can say artifacts key. For now, just assume that it has the artifacts key, and from where we will see how to pass that artifacts. Okay, so what I'll do is I'll say context dot artifacts, and this will be a dictionary. Assume that it's a dictionary, and I'll tell you how you can assume that. So I'll say model directory. So this will give me the model directory, and the model, by model directory I mean this model files directory. Okay, so I'll say model dir. And then from this model dir, what I want to do is I want to run these 2 methods. That is, I'll just copy these two methods and I'll paste them here. So I want to run tokenizer and model. Now I don't want to pass this, you can say this Hugging Face string. Rather, I want to pass my model directory here. So I'll just pass model dir here. Now after this toke and model has been defined, I need to also attach these to this instance of SBERT. Okay, so I'll say model, self dot model is equal to model, self dot token is equal to token. Okay, so what is the next step? Next step is to implement the predict method. Now, where will this predict be coming from? And it depends on you. It depends on how you want the model input to be passed. Let's assume that it will be passed as a pd.data frame. Now, for that, we would need to define pd. So let's define pd here. So import pandas as pd. So we are forcing it. You could have just accepted a list. Okay, so that is up to you. Now, what we want to do is we also want to return a PD. So we want to return a data frame with a key called predictions. And this prediction will be having some, let's say, embeddings. Now we will be creating these embeddings for now. Just for now, I'm creating the, I'm setting up the inputs and output context of this predict method. Now, for this model input, I'll assume that it has a text field. Okay, so this predict has a text field that we want to reference. So what I'll do is I'll do something like model input. I'll grab the text and I'll convert it into a list. And why I'm converting it into a list? You see, when I tested this model, I had a list, right? So that is the rationale. So I'm telling you my rationale of why I'm basically writing out certain line of code. So I'll just say texts. Give me a minute, 1 second. Okay, so now that we have the text ready, what we have to see, what we have to do? We have to do the exact same thing that we did here. So I'll just grab my input here, input from here, and then I'll grab my with dot torch dot no grad. Okay. So I will get my outputs, and after outputs, I get my hidden state. And if you recall, this hidden state was giving me a entry which is of the shape. So I have to mean it. So I have to mean it across one axis. So I'll just try to mean it across first axis and see what happens. So you see, I have meaned it, and now I am only getting entries like this. Okay. So now what I can do is I can just take this and return this as it is. So I'll just take my last hidden state and get the mean, get the axis along the axis 1, and I'll name this as embedding. Okay. And this embedding I'm returning as the prediction. So this is my custom SBERT model. Now what do I need to do next? Let's see. We implement this model. And the next thing that we need to do is we need to take this and register it in the, so first of all, we need to log it before registering it. We will be looking at that next. Okay, so for that, let us now move to the notebook and let's see how are we going to register it. Now, not register, but before that, we need to log the model. Now to log it, anything that has to be logged using MLflow, it has to be associated with a run, and run has to be associated with a experiment. So what we will do is, first of all, we'll create the experiment here really quickly. So for that, let us first of all check our path, because experimentation looks different than what we do locally. So I'll just get my current working directory. So I've got this. Now what I need to do is I need to set my experiment. So I'll do set experiment, and under that I can do something like, I can grab this also, or if you wanted to be fancy, then you could have just appended it. So I'll just name this experiment as logging SBERT model. Okay, so I'll just run this. Now this will create the experiment. So it says it is creating it. Okay, now after that we can create a run context. So with MLflow.start run, within this run I will be logging the model. So you see all this code is already being provided. So what I'll do is I'll just run MLflow.log model. Now this model, we need to provide 4 pieces of information. First is artifact path. Artifact path, it will be a certain thing. We will fill out these details, but let us first of all see what all we need to pass here. We need to pass Python model argument. For now I'm just putting this as a string, but let's wait. Python model. After that I need to pass the actual artifacts. Okay, I'll see what has to be filled here, and then we can pass input example as well. See, all input example is not required, but it will make your auto generation. So basically what what Databricks does is it auto generates the scoring script. So if you want that to succeed correctly, you can provide input examples also. Now, what is the artifact path? It can be anything. You can provide anything, any string that you want. I'll show you what exactly this does once the model is logged. Then Python model. Python model will be the actual class instantiated. So I'll just take my SBERT model and I'll call it. Then in the artifact, it will be the dictionary which is we are fetching here. So context.artifact. So I need to provide a model directory here. Model directory. So what will be my model directory? So I'll just grab the path here from here. So this will be my model directory. What will be the input examples? We saw that in input examples we are expecting the text to be there, right? So I will create a data frame with a key called input example with a key called text. Okay, so sorry for the disturbance. So what I was saying is in the input example, we have to pass in the same format in which we are consuming it. So we need to have a text field and we can provide maybe a list. This is input example. Okay. So now it should log the model. Okay. So let's log it and I'll show you what this artifact path means. So I'll just run this, but this time it is going to take some time. Why? Because when I call this SBERT, it will run all these steps. Okay. So it is going to take some time. Let's wait for it and let's see how much time it takes. So it says it has no attribute called log model. Why is that? MLflow dot. Okay, sorry. I think I need to pass the py function model. So it's not a normal model, but rather py function model. So let's wait for some time and let's see how much time it takes. So it's loading. It's still doing its job. And you see loading waits. How it is loading waits? Because we have called these two methods and it is looking at this model directory and it is loading these things in here. Okay. So let's see. Yeah. So it's completed. Now let us open this run and I'll show you certain things. So when I open this run and if I navigate to artifacts, you see this model name. That is what is being referred here. Artifact path. Let's say I register, I log one more model as model 2. And if I run this again, this will come out as model 2. So let's wait for it to complete. Okay, so now if I open this experiment, this is going, not this experiment, but this run, this will be model 2. And this model has all the things like artifacts, model files and things like that. Okay. All right. So I think something in place of model files, if I do this, let's see if this solves the issue. Because currently the files are coming, this directory is also included somehow. I don't know why. We should not have this directory here. Okay, let's open the run. Why it is including the directory? That's a good point. 1 second. Artifact. Yeah, this time it's not including the directory. So that is why I was concerned. Okay, so there are some warnings. Fail to run predict on input example. Dependencies introduced in are not captured. It's saying, okay, so what exactly are we getting here? Okay, so somehow, okay, so what is happening? We pass this and so what? Fail to run predict on input example. Okay, so it is basically taking the input example and it is trying to run this. Okay, but why it is failing? Can't we call? Let me do one thing. So let's take this and let's call text here on this data frame. Yes, it's working. And let's say if we call toList and see if it's working. So why is it failing then? So we are able to load the list and then okay, okay, fail to validate serving input example data. Okay, let me see. Let me debug this. Give me a sec. So I saw one issue which could have produced this because we are directly calling this tokenizer. We are not calling the self.tokenizer, self.model. Let's run this again and let's see if this solves the issue or not. Okay, so let's set the experiment and then after that let's run this again. This time I think that was the issue, but let's see. Let's wait for maybe 20 seconds again and see if we are able to log the model correctly. It's still not working. Fail to validate serving input examples. Why it is failing here? Okay, so the issue was not how we were passing the data, but rather how we were returning the data. So earlier, if you recall, I was using this as the return value, which is basically a PyTorch value, and it is the MLflow was not able to understand it properly. So now what I did was I just looped through it and I created this list of embedding values. So now we'll be getting this clean embedding list, and now we are able to run this log model method. After the log model method, we have to basically, next step is to register this model. Registering is different thing. Logging is associated with a run and registration is associated with the model catalog. And model catalog works differently in the what you can say in the Databricks. So you have got this workspace, and inside this workspace, so workspace is the catalog name, default is the schema name, and inside this default you have to basically provide your model name. So I'll just define the model name here really quickly. Let me also yeah, so I'll say workspace is the catalog name, dot default is the schema name, and this sbert model new one. Okay, new one is my model name, and then I will have to also get my logged model URI, and it follows the method like runs and then ID of the run and then finally the model. So let's grab this from the run itself. So I'll just open this run which logged the model, and from here I can get the artifact, and you will see here model URI here. Okay, so I can just grab the model URI from here and then put it put it here. Okay. And then after that, I can register my model. To register it, I can call MLflow dot register model. So MLflow dot register model, and I can pass the logged model URI and the model name. So let's run this. So let us wait for it to complete. So successfully registered model. Now we should be able to see the model. So now you will have a versioned model in the workspace. So if I open this, if I open the default, you will get SBERT model new one. So this is our model. Okay, you can have multiple versions within the same name. Now finally we can serve the model. How are we going to serve? Serving is quite easy because all the hard work was in understanding the input-output format, creating a custom PyFunc model. This is where the real work was. Serving is quite simple. Okay, 1 second. So what we need to do is, okay, let me go back to that page again. So I'll just come here to the catalog. I'll open the workspace. I can open the schema. I can open the SBERT model new one. And for this new one, I can click on this serve this model. And the only detail that I need to provide here is SBERT new model, or whatever you wish to have it named. So you will get this URL. That URL is something that you can use for calling it. So if I go ahead and create this right now, it will take forever. It takes about 30 minutes to spin up. Last time it took 30 minutes. So that is why what I'll do is I'll go to serving and I'll use the already created one that I have. So it has the same configuration and all. I'll just use it and I'll showcase you how you can basically work with it. So now that we have done all the hard work of creating these endpoints and all, you would want to use it and consume it, right? So what we can do is, once your endpoint is ready, its status will go from updating to ready. And if you click on it, you will be able to see all the details about the endpoint, like what is the URL and what is going to be the configuration of the endpoint. And besides those details, you will be able to see the latency, request per second, response rate, GPU or CPU usage, whatever you are using, memory usage. So all the monitoring and observability you are getting for free. Now, how do we consume this model? Okay, so to be able to consume it, you would need to first of all come here and open the settings tab. Under the settings, you would want to grab the Databricks token. So I'll go inside the developer and I'll navigate to this access token. I'll click on manage and I'll generate a new token. I'll name this as testing and I'll put the lifetime as 1 day. Let's generate it and let's grab this token. Okay, let's go to the Databricks and let's create a new testing notebook. 1 second. I'll just open a new tab, maybe new notebook, and in the notebook I'll paste this token. So I'll name this token as HF token, and I would just make it as a string. Now I will come back to my endpoint. I'll go here and use, and under the use I'll go to Python and I'll grab this code. Now under this I see this option for Databricks token. I'll just remove this and I can, not HF token, sorry, because we are dealing with Hugging Face, so I thought it's HF token. So I'll call this as Databricks token, and I'll paste it right here. Now, you see all of these have been auto-generated. And the reason for that is because we provided all the context of what will be the input data, what will be the output data in our custom PyFunc model. So this is why Databricks is able to generate all these details. We did not have to provide the scoring script as well. So I'll just first of all attach the serverless compute to this notebook. It's ready. If I run this, it's now ready. Now what I can do is I can score my model. Okay. Now in the scoring, I want to provide the input example. Now input example will be a data frame. So I'll just create an input example really quickly. pd.dataframe. And I would like to pass a text. And this text would be, this is a test maybe. Now if I run this, it says, okay, so I think input example we need to pass. If I run this now, it will hit the SBERT embedding serving. Now it might take some time because the model, the endpoint that I have been using here was an older one, and it will basically spin up the servers to start the process, and then only it will be able to make the scoring. So it will take some time, some maybe 1 or 2 minutes as well, for this to warm up the instance again, because our concurrency is set to 0 to 4. So because of not using the instance for some time, it has been switched off, and now the instance is being like wake up in the wake up mode. Currently it's not it has not completely woken up, otherwise we would have got the response. So it is taking some time. Let's wait, and let me pause this video and let me resume it back once this is done. So as you can see now, the results have been obtained. But now that our instances have been warm, if I score the model once again, it will be almost immediately. So you see, it returned the results within seconds. Now, there are some not so recommended ways to keep these instances always warm. Maybe by setting up a server and running a cron job which periodically sends requests to this endpoint, and it keeps the instances warm. Or if you have a use case where the activity is very, high traffic activity going on throughout the day, then in that cases, these instances will be always warm. But even in those scenarios, it's not recommended to basically go for 0 scale down. We usually have to have at least some instances always warm so that we can cater to the request that can come at uneven times. With that said, I think this is what I wanted to basically discuss in this video, in this project, that how do we build such a kind of serving system. Okay, so that's it. You have successfully taken a Hugging Face model, wrapped it inside a custom PyFunc model, registered it in Databricks, and deployed it as a production endpoint. This is the exact workflow used in machine learning systems to deploy models reliably and at scale. So if you found this video useful, consider subscribing to the channel. I regularly post real-world ML engineering tutorials like this. Thank you for watching, and I'll see you in the next video.